Students of the University of Stamina, thank you so much for your guidance, thank you so much for your advice, for your motivation, semangat, sons. Well, I appreciate that so much, and I miss you guys.
I have a great time doing exchange students here because with the friends, the lecturers, and also the new environment for me is really welcoming. So yeah, I learned really a lot here.
Universitas Pertamina, the global leader.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I hope you're doing well today. Before we start today's occasion, I'd like to welcome our speakers, Mr. Abdul Hafiz, Mr. Muhammad Zainul Afwani, Mr. Ahmad Fadilah, and also I'd like to welcome all of the participants. Ladies and gentlemen, welcome to our Environmental Geology and Geohazard workshop. And please allow me to introduce myself. My name is Ratu Anissa, and on today's occasion, I will be your master of ceremony. Before we begin our main session, I would like to remind you to always be safe, be careful, and be aware with your environment. And in case of any emergency, please calm down and reach your safest and accessible evacuation route around you, and then go to a safer place. And that will conclude our safety induction. Without any further ado, we will continue to our guidelines for this workshop. Okay, so please make sure you already entered the room 10 minutes before the workshop starts. And please use your name as the display name. And please turn off your camera and mic during the workshop. And Q&A session will be at the end of each session. And we're going to continue with the rundown for today. Okay, so first we have opening, and then we have introduction to the speakers. And then the first speaker is Mr. Abdul Hafiz with the topic of GIS application, and then followed by Mr. Muhammad Zainul Afwani with the topic of tackling environmental problems with GIS. And then after that, we're going to have a break for an hour. Then we will continue with the third workshop for today with Mr. Ahmad Fadilah with the topic of modeling hydrogeological contamination using MODFlow. And then that will conclude our workshop session for today. Okay, so before we begin our workshop session, we're going to show you a little introduction to Geological Engineering Department of Universitas Pertamina. Please enjoy.
Bapak.
Universitas Pertamina. Thank you so much for your guidance. Thank you so much for your advice, for your motivation, semangat, sons. Well, I appreciate that so much, and I will miss you guys.
I have a great time doing exchange students here because with the friends, the lecturers, and also the new environment for me is really welcoming. So yeah, I learned really a lot here.
Universitas Pertamina, the global leaders.
Okay, so that's a little introduction to our geological engineering department. Now let's begin our workshop session. The first workshop will be delivered by Mr. Abdul Hafiz with the topic of GIS application. To Mr. Hafiz, please, the time is yours.
Okay, thank you. Is my voice? Can you hear my voice?
Yes, sir.
Okay, thank you. Okay, let me share my screen first. Okay. Assalamualaikum warahmatullahi wabarakatuh and good morning. First of all, thank you very much for Universitas Pertamina for inviting us for this great meeting, great discussion, and great workshop. And also, this is a great opportunity for us to share our experience about the GIS application, not only for geological, not only for geological environment, but also in another environment. Excuse me. So this is a broader talk about environmental geology and geohazard. This is not yeah, we cannot talk this topic in one session or in 1 or 2 hours. So let's limit our talk in another perspective. For example, this only in end user perspective. So this we are not the data developer or data provider. So we are the, for me myself, this is myself is the end user data users. By the way, during this session, we can discussion. You can talk me or interrupt my presentation. Probably you are not agree what I say, so just tell me and we can discuss about this issue. Okay, my name is Hafiz from Geosoftware Community. This non-profitable organization, non-government organization, and also we had some project about the social event in probably some in Sulawesi and West Java. Okay, before we start, we'll have some outlines. The first one is the introduction, and then GIS overview, and GIS environment for geology and geohazard. Okay. Well, sorry, myself, my background is in geology and geophysics. Most of my works in geophysics, and my works are related to GIS processing and GIS analyzing. So hopefully during this presentation, I can bring some new insight about GIS application in our works, especially in geology or geophysics, or let's say in geoscience. Okay, for us, for the beginning, let me introduce Geosoftware Community. So this is a non-profitable organization that was born in early March before the outbreaks, and we had some projects, social events, and some webinars And the webinars are related to geoscience by using GIS. And in after Ramadan, we had some sharing and caring workshop. That's this workshop. We open a donation for the COVID outbreak impact for our family, our friends that cannot work from outside. So the donation were transferred to them, especially in West Java. And also there was a flash flood in Masamba and Sukabumi. And also currently we have another project that's water supply in Cikakaban, that's in southern part of Tasikmalaya. So we want to make a drill hole. We want to make a well in this place to obtain the clean water. Okay, that's the introduction for my community. So now just application for environmental geology and geohazard. So before we go to the environmental geology and geohazard, we have to know about the GIS. So this is a great report from Knowledge Transfer Network and Ordnance Survey. They make a report about the power of place. So probably we have know that, or some of us familiar with GIS data or geospatial data. And during this process or during this what to call the insight of geospatial, we probably make some maps about the geological map or geophysical map or surface map. But now the trend of geospatial data is moving to from old style to the new style. That's like web GIS or something like that, and it can transform our or change our life from house from let's say, for example, we know Grab or Gojek, so we can only at home and then we get our food or we can go anywhere with this platform. Yeah, that's the example of geospatial application. Okay. Okay. So what is GIS? GIS is a computer system, which is the end of this system is to analyze, to model, or to visualize the data. And the data is like spatial relationship, pattern, and trends. And then we can make a decision what's the next plan for this object. And then the two keywords from this GIS data is geographic and information, which is the geographic refers to the place and information refers to the data. So now it's the time of big data. Everything, the data, we can gather data from many places and then we can analyze this data. And of course, this is a good data, not a waste data. And then from this data we can analyze and then we make a decision from this data model or visualization. In GIS component, there are 5 components that gather this GIS process. That's people, that's with knowledge of geographic information, and then the data, a good data, not a garbage data, and then the software that can manipulate, can edit, can visualize or model the data, and then a good hardware. And the last, of course, is the method. Without the method, we can stand with our data, or we can stand with our result. With methods, we can tell to everybody that this is a great data, or we can say this is a sound result. In what is a GIS data? So the spatial data or GIS data is related to the location. It's sorry. So GIS data generally divided into two types. That's spatial data and tabular data or attribute data. The spatial data is related to the location or the shape of the feature, and then the location commonly stored coordinate or in coordinate system. We know the latitude, longitude, or elevation. Otherwise, in attribute data, it's like a tabular data with component that describe the data itself. For example, we have a point in a place in a city which only have X and Y or latitude and longitude. Without attribute data or tabular data, the data itself is we cannot do anything with this data because we don't know what data it is. With attribute data from this spatial data, we can analyze quantitatively or qualitatively. And then the GIS data type, it's commonly there are two types of GIS data. That's a vector data and raster data. The vector data is referred to the coordinate of a point or line or area. In when we make a line or point or area, when we zoom it, we cannot see the end of this data. So we only have coordinate of X and Y, and we don't have the end of this draw. Otherwise, in raster data, it's made by a pixel. That's a squares, and then when we zoom it, it's like a photograph. When we zoom it, it will be a pixelate or a break with squares in there. Okay, that's the data type. This is the comparison of this data. And the other important thing from GIS is coordinate system. When we talk about coordinate system, sometimes we refer to the decimal degree. For example, 6 degree point 7 minute, or the other coordinate system is the projected. That's in, let's say, in meters unit. This is important because when we use the coordinate system, wrong the coordinate system will have a wrong or no less accurate calculation. So this is the comparison of geographic coordinate system and a projected coordinate system. Okay, I'm not talking about this object or issue with full talk because this is only the introduction. And what about the GIS works? How does the GIS works? So we have several layers. For example, a road or streams or river or elevation. We stack all of these layers and make one maps. For example, here we have a land parcel data model. We have a survey network, and then we stack with boundaries, and then we stack with a parcel framework, ownership, and so on. And then we'll have a land parcel map. This is the example of GIS works. So when we have only one layers, for example, we only have a river, that's not a make good information. That's only the river information. But when we have some layers stacked in one map, and then we will have another information that we can make a decision from that. Okay, where can we get GIS data? The first one should be from field survey or from mapping, and then from old map or online digital data, and from remote sensing or from satellite data or from UAV data. And can we get a free available data, GIS data? Yes. In Indonesia, we have Indonesian Geoportal, which is it contains the base map of topographic map, and it's free. And then we can get data or street data or land use data from OpenStreetMap. And then there are natural earth, GIDM, and geoboundaries. That's cover for that's a world covers data. And then there is from DEMNAS, that's digital elevation model of a topographic map from that's Indonesian government. And then SRTM and Explorer. That's all of these are the free available data. And there are some another thematic data that's suitable for several subjects. Okay. At the end of this talk will be a demo, not yeah, that's a GIS demo. For mostly for it's about the introduction for GIS data. So we have free software and commercial software. The free software now most of us use Q Quantum GIS or QGIS, and then for the commercial software now it's in ArcGIS by Esri. So most of this data, this software can manipulate or can edit or can visualize the GIS data as the owner's knowledge. Okay, we move to the GIS for environmental geology. Okay, so environmental geology is study of interaction of human with all aspects of their environment, like physics, atmospheric, and biological, and linked directly to the engineering geology. And the end of the environmental geology is to solving the environmental problems using a geological aspect. And what for GIS for environmental geology? The first one is to facilitate environmental management for sustainable development, to model the effect of pollution or public health, for example, and the other example is to find environmental engineering solution to maintain limited resources. Okay, this is a workflow of the geoenvironmental evaluation in urban land use planning. This is a case study in China. So they have they should have factorized data or rasterized maps, and then make some calculation or some processing, and then they have the evaluation of the urban planning. And then the most important is the data itself. The data contains the topographic, that's slope or elevation, and then the ground condition, that's superficial geology, formation from lithology of bearing layer, and then the groundwater and geological hazard. How far the urban place from the geological hazard, for example, or how far this urban land use planning from groundwater. That's all related to the how the GIS work with the environmental geology. And then the next is the other example for GIS hydrological modeling. So the data contains from, so the data should be have topographic data from digital elevation model, and then generate a watershed or delineation stream network, and so on. And then from this result, we will have the surface runoff or hydrological modeling and synthetic hydrograph. And the last one for environmental geology, example of environmental geology is landfill site selection. So most of this data we can obtain freely. For example, for land use, topographic, hydrology, and lithological structure. And then the other data from artificial factor, for example, like accessibility, social culture, and infrastructure, it should be like field surveys, and then gather the data and analyze it. From this data, we can obtain where the best place for a landfill site. For the next session, after my session, my colleague from Esri will talk about where the best place for a landfill site selection. Okay, we move to the other slides. Okay, for Indonesian government have some technical guide how to make maps for the specific maps. For example, planning for the sea area, ocean area, or for the urban planning. Okay, for GIS for geohazard. In geohazard, we know about the risk, hazard, vulnerability, and capacity. All of these components were calculated and result a new insight or new knowledge. For example, we have a hazard about flooding area or wave depth or another hazard, and then we compare with the human activities or environmental or socioeconomic or infrastructure. From this data, we compare also with the risk or impact, and then we will have vulnerability map or hazard map or exposure map. These all we compare or we combine, and then we will have the risk analysis. This is what geohazard studies works. Okay, this is the example of geohazard studies. The first map is about the landslide map. Where's the high vulnerability of landslide and where the low vulnerability of a landslide. And the other map is a flood map. Where's the map the flood vulnerable or the risk of a flood will happen. In this is the map of Jakarta, and the other maps is earthquake map. This is the data gathered from 2019, January 2019 to date. And we can see that the earthquake ranging from west to east and also to the north part of Indonesia. So most of Indonesian places are vulnerable of earthquake. So that's why the geology taking place. Where should we make or we maintain the people or we maintain our public facility and so on. Okay, this is a GIS landslide accessibility mapping. We need the data like DEM or digital elevation model, that's a raster data, and then field work or satellite data and meteorological data. So this is the example, not the exact method. So there are several methods for this susceptibility mapping, not only this one. So all of us can make another method with specific or studied data. From this data, we have a training, landslide, and validation. This is the core of this like susceptibility, or like in machine learning, we have to train our data and validate the data. And then this data, after we have like a validation or predictable data more than 90%, then we can make a susceptibility map. This is the example of landslide GIS for landslide. The other example is the GIS for flood. So in several places, the flood can take place or can happen incidentally, like flash flood. We can analyze this data or this history of flood by using GIS data. The data itself, probably it's not clearly seen. We need a digital elevation model, and then the land use, land cover, lithology, and soil type. Those data we combine and we make another derivation from this data, and then we will have flood hazard or spatial distribution of flood hazard. So this is an example. Another example is the GIS earthquake. So to estimate the loss estimation based on immediate extraction of damaged building. So we have building data, building damage, and then we calculate how big the event or the earthquake, and then we calculate how much money we lost from this post earthquake, and then we can predict the next earthquake. What should we do for the next earthquake or for the next planning? Okay, that's the example. Luckily, in our government, have several technical guidance from national hazard mitigation. So they have for the level region or city level. This is for the province, and this is the guidance how to to mitigate the hazard. Okay, the most common data for geohazard. This is not the only data. We have several data or thematic data, but in here, this is all of these data we can use for all of the hazard or geohazard mapping. The first one is the digital elevation model, and then we can derive this data into a slope or aspect, or even into 3D data. And then a topographic map. We can gather, for example, a river or stream, and then a place or another important place from topographic map. And then a lithology map, soil type, and meteorological data. For example, the rain data, or the sun radiation, or the wind direction, or so on. Another example is like the earthquake data, or the history of flood, or the history of landslide, and so on. That's all data we compare and then make a hazard map, vulnerability map, or susceptibility map. Okay, that's the data for geohazard. And then what can we do with this data with GIS? Well, in GIS, we can, after we analyze or model the data, so we can prepare ourselves what will happen when the landslide happen, or the earthquake with several magnitude or certain magnitude in a place. What will we do next, like that? And then when after the event happen, we should recovery or rehabilitation. Where should we stay, or what's the short-term plan, or so on. And then we can make a prevention or mitigation and relief, like where the logistic go, or where the logistic coming from, and so on. And then there is a response and prediction and warning. So we can predict with a hazard map or vulnerability map, and then warning to our people, to our colleagues, or to our friends that that's not a best place for stay, for example. Okay. GIS for environmental and geohazard. So that's like the previous slide. It's provide information of vulnerable area, mitigation rescue, and help for planning. And then integrated geospatial information framework. So there are some subject or object that involved in the GIS framework. That's like governance, how good the governance work from our government, and then the technology, can we adopt a new technology, and then our people. From this framework, we can gather a new knowledge or new decision, or a new prediction and warnings. So like a governance and institution work together, and then make a policy and legal, and then from financial support, and then we will have a capacity and education or communication engagement. That's all related to our geology, environmental geology or geohazard mitigation, warning, and planning. Okay, GIS in near future. So today's most promising GIS trend is like data analytics, real-time data collection, open source mapping and matching, machine or deep learning. So all of this GIS trend now will move to the next technology, like Internet of Things, or location-based augmented reality, or autonomous vehicle. So for example, we are living in the most active tectonic place, and then when we adopt a new technology like autonomous vehicle, and then it's based on the place or coordinate system or a satellite. When we have a tectonic plate move, and then what happened with the coordinate system, with the road, for example, is it move also or change? That's all the technology, and we have to adopt with this technology. And for a conclusion, by using a GIS technology or GIS knowledge, we can prepare ourselves or recover, rehabilitation, prevention and mitigation, response, prediction, and warning to our self, to ourselves or to our family, to our college, and so on. That's all for this introduction of GIS and geohazard and environmental geology. The next session is demo data. Okay, not a demo, actually, that's only to show you that we have several data that we can show you. So the next session by my colleague, he will introduce us about how GIS work with landfill site selection, or where the best place for the landfill selection. In here, I want to show you that the data I want to show you that the those data, what kind of data that GIS works. Okay. Sorry. So okay. I have tell you that there are some data in GIS. The common data for GIS, that's like DEM, topographic map, lithology, soil type, and so on. So here I want to show you, for example, the DEM data. DEM data is, it's elevation. That's contain the pixel or the data contains the elevation from X and Y, and also the Z. So this is the elevation map, which contains the elevation from sea level. Another data is like a river or land use or slope. These data were gathered or derived from GAM data. This is river data in raster type, or this is the land use. This is the slope, and that's the elevation. The other data is the vector data. For example, the geological formation. From this data, we can make another analysis, another example, another great analysis from geological information. Okay, let's see another data. That's so we have elevation like this, continuous data, continuous raster data. And when we make a derivation from this data, we make, for example, a slope. We can analyze where the high slope data or where there's low slope data. So sorry, this let's make a smaller area. The next session, my college will show you how to make landfill site selection by using ArcGIS software. This is a QGIS free software, and you can use it freely. So I changed the coordinate system. Okay, and then we have another like a hill shade or the terrain model. This is the example of the GIS data, and then we can derive the elevation model into another model like like a hillshade or like a slope or another derivation. Okay, that's all from me. Thank you very much, and I give back to the master of ceremony.
Okay. That was an interesting topic, Mr. Hafiz. Thank you so much for delivering such a great presentation. Now let's move on to Q&A session. If anyone wants to ask a question regarding the topic that Mr. Hafiz just delivered, please just simply turn on your microphone, state your name, and followed by the question. Is there any question?
Okay. Yeah. We wait for the. You can ask me whenever you want. Before there are some. So I talk about before that I talk about the free available data that we can gather freely online. For example, from Indonesian Geoportal. This is coming from information agency. This is the website tanairindonesia.go.id, and then we can download several data from this website. For example, we can download a topographic map by region or by uh, let's say kabupaten, or we can download the scanned map. That's a topographic map in GP format, or it's a C map, or economic exclusive zone data or maps, and this is the Geohazard maps. Okay, let's see. For the first one is the Geohazard map. Okay, websites. Okay, let's see another maps. This is the province in Indonesia that have a geohazard more than the other places. So, for example, from South Sulawesi, Banten, Central Sulawesi, Nusa Tenggara Barat, Bali, and Maluku. We can see what data in there. Just see select pilih wilayah, and then we can see RBI or topographic map for scale 1 by 5,000 or 1 by 25,000. So in outside of Java or Bali or Nusa Tenggara, the map, the detailed map data is only about 1 by 50,000. It's different from Java. It's 1 by 25,000. But in the region with geohazard or most geohazard event, we can gather until 1 by 5,000 scale. And then we can just press click or click download data, and we will have the data in our computer. This is the example. Another example is topographic map. We can download based on area of interest or based on region. But first, we have to register ourselves by click register. And then we fill our name or username or so on, and then sign up. And then after sign up, we can log in. Okay, this website sometimes not works. We just press login. Okay, probably this the website is down, so we cannot go furthermore. But this is the first example. Another example is RBI or topographic map. That's the scale ranging from 1 by 1,000 to 1 by 1 million. So we can select the data or the map freely. Another map is kebijakan satu peta or one map policy. This data can only be opened by the important person like a governor or a bupati or the governmental person. So this is not for public. This is a DEMNAS, digital elevation model that I said before. This data contains scale or resolution to 8 meters. So we have to register first, and then we get a password. We go to DEMNAS, Digital Elevation Model Nasional, or BATNAS. BATNAS is Bathymetric Nasional. First, we select a DEMNAS. Okay, that's it. We can download the data directly by pressing the tile that we want. We can download all of them in one time, but we have to download one by one. For example, we want to download the data from Surabaya. Just click on this map, and we will have the link like this. Okay, another example in Kalimantan, for example. We click like this, and then the link will appear here, and then just download it. It's the same way when we download the scanned map. Another data is BATNAS or Bathymetric Nasional. The scale is or the resolution, spatial resolution is not too good for the analysis. But for the low scale analysis, we can use it. For example, this one. We can download it, the elevation above the sea level or below the sea level, like this. just press the link here, and then we will have the data. There are two types. That's MSL, or meter sea level. This is a measure by sea level, and then EGM by geoid or datum. Yeah, the data itself slightly not different, not have a big difference. So we can download one of them. So this is the example of free available data from our government. Another example is from OpenStreetMap. OpenStreetMap provide a free online data that's like a road or buildings or land use. When we download the data, we go to the OSM export tools, and then we have to log in or sign up. When you don't have your account, just sign up, and then you will have your password, and then give the tools to authorize ourselves, and then go to start exporting. This is the exporting view. We just select the area you want to download. For example, in Bandung, we zoom into the area of interest and make a box here, or draw, or this view, or this all of this area. So we select a draw box, click and click, not drag. It's just click and click like this, and then give a name like this, and give a description. And what project is this? And then we go to the next step. These tools give us a selection what data type we want to use. For example, we want to use a GeoPackage or save file or another data format. In GIS data, the most common data format is shapefile or GeoPackage. You can use one or these both data type. Here, for example, I use a shapefile, and then go to the next step. We can use what type of data we want to download. For example, a building. The building itself, there is a building name, address, and material and condition. Or we want to download a commercials, that's shops, supermarket, and so on. Or we want to download education, that's kindergarten, school, college, and university. We just select we want to download and go to next and publish this export. When we click publish this export, we can download this data anytime, and another people can also download this data. But when we not tick this selection, then other people will not download this data, cannot download this data. Okay, I just press publish this export and create export. When we create export, it will be like this. It's running, and in a few seconds, it's depend on how big the data we select. The bigger data, and then the more time we need to process the data before we download. We just leave this page, and we can close this page, and then the data will arrive in our email. So yeah, the data will the data will be downloaded from our email or from this page. But yeah, we can leave this page when we have another project. Another cool tools from this tools is we can download the history of our download. So for example, a couple of months ago, we download area from another city, and then we can re-download this city. So it says 0 byte, and then we can rerun this data, and then we can download the data. Another example, when we tick show all export, and then we put the name or another description like this, and then we can download all of the related search like Kota Bandung, land use, and so on. So this is from owner. We can see the owners. This is me. I made this data before, and then from this one and this name. Yeah, we can download this. For example, this for their final project. Just click it, and then we can download this. It's so yeah, it's easier to use. Okay, this is the second example of free use data. Another data is from Natural Earth. This is a global coverage data. So it's not the scale is not good, or the resolution is not as good as from Tan Air Geoportal. You can download the data like cultural or physical or raster. Cultural is like the boundaries or the river or the most populated places. And then physical, like let's see what's in physical data. It's like major island, minor island, reefs, ocean, and so on. This is physics data, not the whole data sets. We can download the data without selection. Just click this link, Natural Earthquake Start Kit. It's a 200 megabytes, or in GeoPackage. Yeah, with GeoPackage and shapefile, it's a spatial data format. Okay, this is the third, and then the next example of a free available data is from Earth Explorer. Just click this. Most of geologists download this data from Earth Explorer. For example, land use or Landsat or Sentinel data, or let's say a remote sensing data. We have the display like this, and then we can preview the data before we download it. For example, we want to download data from Bandung. Just click this area. Just click without another options, and then the coordinate will appear like this. And then we go to the data sets, and then we can select what data we want to download. For example, we want to download digital elevation. That's from SRTM or another data provider. And this is a land cover. It's a land cover of this area. For example, the urban area, or forest area, or the water body area. And there is a Landsat. Landsat is a satellite image from a Landsat that's contain Landsat 8, 7, 4 to 5, and 1 to 5. So we can download this data freely. For example, for Landsat 8, just click OK. And then in additional criteria, we can select how much the cloud cover covers the area. We can select just yeah. For example, we need area with less than 10% cloud cover, or in yeah, that's another options. And we click result. And this is the result. This is the preview. When we see blank like this, so there is no data in there. This is the preview. Okay, so this is another preview. Click this one, and then we can see the preview like this. so we can download the satellite image freely. And then we can select this download button. And but before we download this data, we have to log in first. But this is just the example. So this is we have to download what data we can download. There are some small size data, so 4 byte, 1 megabyte, 2 megabyte, 8 megabyte. For the whole data, we need to download this 800 megabyte. Just click download and appear in our computer. So because I'm not logged in, so it's not it will not download directly. So there is a login. Oh, sorry, I'm logging here. So there is a login option here, and then we click here, and then we can download it. That's the data. Okay. The last one I want to show you from SRTM. This is a digital elevation model data that covers almost whole world. And the resolution is about 90 meters. It's different from DEMNAS. DEMNAS is about 8 meters. So we will have a lower resolution, spatial resolution, but with a wider coverage. Okay, that's the example of downloading data. The next session will be how to use the data. Okay, please, if you have some question, just ask the moderator or open your microphone.
Okay, sir, there's a question from Matrisno Mulyo. He asked, apakah bisa untuk memprediksi sedimentasi di suatu sungai di satu tempat tertentu secara kuantitatif? Terima kasih.
Yes, we can predict the sedimentation by using the field data or from GIS data. It's like a prediction only, not the real data. It's a prediction. For example, we have a topographic like this, and then we have the soil type. Do we have a soil type here? Okay. We have a soil type, for example, in this area. So in soil type, it will have like how thick the soils or how depth the soils in there, or what kind of the soils components, for example, the grains or the organic materials and so on. And another data.
Okay, it seems like Mr. Hafiz had some technical difficulties, so while we wait for Mr. Hafiz to come back, please be patient and I will conclude some of Mr. Hafiz's topic. So,
sorry, my
Mr.
connection
Hafiz, okay.
was lost. Okay.
Yes, sir, it's okay.
Okay. I continue my my explanation. So we need first the elevation data, and then we need the stream or the river data, or the like debit debit value, and then the other data is like a soil type and lithological type. From this data, we compare or we combine, and then we will have like how thick the sedimentation in this area, or how big the sedimentation rate in 1 year, or we can calculate how far the sedimentation, or how big the erosion soil in one places. It's depend on how good the data we have. That's the example. So the answer is yes, we can predict. We can predict, but we have to validate with the real data. Okay, I think that's.
Okay, thank you, sir. And the next question is from Yosi Andika. Is how to solve DEMNAS no data and how to use DEMNAS to define DSM.
Okay. DEMNAS, as I said before, DEMNAS is a digital elevation model from information agency, Indonesian Information Agency, Geospatial Agency. Sorry. Sometimes the data is have a no data or no value, and sometimes the data is in different coordinate system. So the first, how to solve it, this let's see what kind of the problem you have. When you have no data, then we try to download a game or another link and see what the result. So this is a technical issue. So probably we have to see the your screen in what kind the issue shows. And the other question is the second question. Sorry.
It's how to use DEMNAS to define DSM.
Yeah, well, DEMNAS in digital elevation model data, so there are several types like DSM or digital surface model and digital terrain model. Digital surface model is include the vegetation height or the house or building height and so on. While in DAM or digital terrain model, it's only the surface of the ground. When we use DEMNAS for DTM, from DTM to from DSM to DTM, we have to make some calculation. In QGIS or in another software, there are some raster calculator, or we can use a processing toolbox. There's a processing toolbox, and then we can just select. There is a filter like DTM filter, so it will filter the data or remove the elevate the height of vegetation, remove the for example the building elevation. Yeah, we use a filter or manual filter by remove the obstacle manually. I think that's the answer. There are several methods, but here I show you only in QGIS, and probably in commercial software there will be powerful tools for the filtering data. Okay, I think that's the. I hope the answer can answer the questions.
Okay, thank you. Yosi Andika, are you satisfied with the answer, or do you still have another question? Okay. The next question is from Putra Bagus Panji. Can we access the technical guidelines for disaster map from BNPB by online? And can you use it to make a disaster risk map, landslide, flood, etc.? Thank you.
Yeah, BNPB or National yeah, BNPB, we can access the data online. I forgot the link. Probably that's INA risk. So the websites like this, and then we can select what kind of data we want to see. So the link is inarix.bnpb.go.id. So for example, banjir or flood or bahaya, like this. And then we sorry, this is okay. And then we can apply. So this is the online data of the from our government. Okay, it's not appear here. Okay, it's still loading. Yeah, the link is from inarix.bnpb.go.id, and we can select the data like flood, flash flood, extreme weather, extreme wave, abrasion, earthquake, and so on. And then we can select the base map like topographic, fault, watershed, bathymetry, and so on. So this is the website from BNPB. Another data or another service we can use like web map service or web mapping service or web feature service. We can use this service like API. It's we can use the link and we put in our GIS platform and select what kind of data we can see. For example, here I have in QGIS or another GIS software, probably in ArcGIS or another one. Let's see, we have a BNPB here, and then we have a darurat or emergency, and then like this, and then we can select here, and then we can see what's the data itself. This is the data. It's online data, and I put in QGIS, and this is the result. For example, this is a shake map in Nusa Tenggara, and this is the result. Another example like earthquake data. So this is just the example. You can use another data, but the first one should be we have to like a permission from this organization, from BNPB, because this is their data and we have to make this data legally. This is the data online, and we can download this data. Okay, this is the example. This is from Nusa Tenggara. Another example from Halmahera or from yeah, let's say in Mentawai. This is the risk map of tsunami in Mentawai. Let's see in world map. Okay, move to back. Okay, this is the risk map of tsunami in Kota Padang, in Padang City. The red means the higher, sorry, the green. Sorry, probably this is flip symbology. So the higher risk in red color and lower risk in green colors. And so this is a map. We also can use base map from, for example, OpenStreetMap. Here, okay, what's wrong? Okay, let's another piece map. Google satellite, for example. Okay, this is Google satellite. And move to button. And okay, so we can see where's the data itself, and then you can zoom in, zoom out the data, and we can see what's the something like this. So this is the GIS technology, and we have to adopt this technology for our daily life. Okay, I think that's the answer. Hopefully, it can answer your question.
Okay, thank you, Mr. Hafiz. Mr. Putra Bagus Panji, do you have an additional question? If not, we will continue with the next question. Okay, it's enough. So the next question is from Mr. Hengki Purwonegoro. He asked, bagaimana dengan Marine Geohazard? Apakah data tersedia untuk analisa?
Okay. Marine geohazard, it's like a landslide from marine, submarine, landslide submarine, or the tsunami, or like something like that. Okay, that's not, I think there is no online data like that, but we can gather the data. We can, for example, we can make our data by ourselves. But first, we have to make the data combination, or the data, the composition of the data. For example, we need the bathymetric map, and then the bathymetric map we can download from Demnas or from Batnas, the bathymetric map, and then we need the, for example, the the boat or the ship track line, for example. Yeah. So first we see the satellite map or the bathymetric map like this, and then we need the sorry, it's we need like ship track like this. Make it bright. For example, we need ship track, and then we need like where's the event history and so on, and then we can make our data. But of course, we need the method. We need the what kind of the method we use. But the data itself, we can gather one by one. I think that's the answer.
Okay, Mr. Hengki, does that answer your question, or do you have any additional question? Okay, we're going to continue with the next question. The next question is from Mr. Badrun. Mr. Badrun asked, how is the accuracy of the topographic data provided by the Demnas portal when compared to the topographic data from Google Earth satellite imagery? Thank you.
Okay. So this is hard questions. For the Demnas elevation model, it's the spatial resolution is about 8 meters. So 8 meters horizontally and also vertically. So otherwise, from Google Earth satellite map data, sometimes the satellite data is only have the imagery, not the elevation. But also sometimes the satellite data contains elevation. In Google Earth, I'm not sure, but probably it use SRTM data. Okay, let's see. We use base map from Google Terrain. This is the data. Sorry, it's getting dark. Okay, this is the terrain or the elevation of the Google Earth. Okay, it's dark. Okay, let's make it brightness. Multiply brightness. Yeah. Okay, this is just the example. Okay, we can calculate the spatial resolution of this data by measure the pixel data. But it seems that this is a high resolution data, and we have to see the guidance from Google Earth. But probably it use SRTM or ASTER data. It's about 30 meters spatial resolution or around 20 meters. So compared to DEMNAS is about 8 meters. I think that's the answer. So we can use it for the lower scale. When we use DEMNAS, we can use it for a higher scale. Okay, I think that's the.
Okay, Mr. Badrun, I hope that answers your question, or do you have any additional question? Okay, we will continue with the next question from Mr. Ahmad Humam. He asked, sometimes when I usually working with spatial data analysis, I use DEM data for better accuracy, but in some analysis, such as generate slope percent value or generate the drainage patterns, I can't deal with the smoother results. So I try to use SRTM and make the better analysis, but SRTM has minor accuracy data than DEMNAS has. Such a dilemma if I want to get more accurate result. Can you give me some tips to deal with these cases? Thank
Okay.
you.
Okay. Yeah. Okay. Let's see what we have here. Okay. DEMNAS. For example, here I have a DEMNAS here, and okay, it is in. So in my previous slide, I said that there are some a type of coordinate system, and for the online data, mostly the data in WGS 84 or APSG 43226 coordinate system. So we make it in proper coordinate system like this, and when we make a slope from this data in I said that 46 coordinate system, that's decimal degree units. First, you have to change your data into. Okay. Okay. So you have to change your data into a planimetric coordinate system or in a projected coordinate system. This is my DMNAS. I change the data into my data projection into a proper coordinate system. So this is from North Sulawesi. It's about 51N, and target. Sorry, it's in 51N, and just click run. And then we have a reprojected data like this, and this is in This is in a meter units. We change our coordinate system into a UTM or a projected coordinate system. So in 51N, okay. And let's make a slope. This is the slope and the projected. So there is a option, we make it in degree or percent. When we press this option, and then we will have a percent result. When we do nothing here, and then we will have degrees units. Sorry, a meter. Sorry, in degrees unit. It close, and then this is the result. So the slope of this area is in 0 degree to 64 degree. Yeah. We just make sure you have a proper coordinate system. Usually use projected coordinate system depend on what area you are. This is in degree. For example, we change into a percent slope. Okay, just click this option and then click run. So we have percent from 0% to 200%. So 200% means more than 45 degrees, or it says 64 degrees. Okay, I think that's the answer. Hopefully it satisfies your questions.
Okay, Mr. Humam, do you have any further question? Okay, that's enough. Thank you. Okay, does anyone have any question? We're gonna wait for a few minutes for the questions. If there isn't any questions, we will end the first session of today's workshop.
Okay, one important thing when you deal with GIS processing is the method, what method you use. So sometimes in one analysis, for example, flat analysis in GIS, several researchers will have a different method. So make sure you have a proper method for your analysis. And the other one is the data. Make sure you have good data for your analysis. Just like Mr. Humam said that sometimes it has a good answer, a good solution, but sometimes also it has a lower resolution. Okay, I think that's the.
Okay, it seems like there isn't any other question. So, Mr. Hafiz, before we end the workshop, do you have anything to say to the audience or a suggestion for us to make our work with GIS can be more efficient?
Okay, first, thank you very much from Universitas Pertamina for this event. And I'm sorry, probably during my presentation, you cannot understand what I said. So this is a hard presentation I have ever attend. And make sure when you deal with GIS data, you have a proper method, you have a good data, and you have enough source to make your analysis. And make sure you consult your data to the other college to make sure that you have a real result, or the result is just like what you want. I think that's from me. Thank you very much for your attend, and thank you.
Thank you, sir, for the great presentation. So before we end the session, I will conclude Mr. Hafiz workshop. So from Mr. Hafiz, we learned about what is GIS and what GIS can do, and especially for environmental geology and urban planning, such as facilitating environmental management for sustainable development, modeling the effects of pollution on public health, and finding environmental engineering solutions to maintain limited sources. And we can get free or paid raw data, and for free data, we can visit Landsat website, DEMNAS, etc. And we can use various methods to analyze the data so we can get the result we want to comprehend the complexity of the area or for future research. And in the end, our analysis can make bigger impact, a better solution for the world. And that's the conclusion for Mr. Hafiz workshop. And before we end, lastly, we're gonna have a photo session. So to Mr. Yuda, please take the, and our audience, can you please turn on the camera for the photo session?
Okay, for everybody in this room, please turn on your camera for the documentation. Okay, I will count until 3. One, two, three. Cheers. Okay. This why. Once again. 1, 2, 3. Cheers. Okay, thank you.
Okay, thank you, Yuda. And once again, thank you, Mr. Hafiz, for the presentation. And we will continue with the second workshop for today. The speaker is Mr. Muhammad Zayanul Afwani with the topic of tackling environmental problems with GIS. To Mr. Zayan, please, the time is yours. Thank you, sir. Okay, it seems like Mr. Zayan will arrive a few more minutes. Please be patient. Okay, while waiting for the second speaker, Mr. Zayan, if anyone wants to take a break or anything, please do.
operasi dan produksi. Berbeda dengan program studi di universitas lainnya, program studi teknik geologi di Pertamina mengedepankan metode active learning dalam ajar mengajar, di mana mahasiswa dituntut untuk lebih aktif dalam kelas dibandingkan dosennya. Selain itu, kami juga mengedepankan kerjasama multidisiplin, di mana mahasiswa dituntut untuk bekerjasama antar jurusan mengerjakan real dataset dari Pertamina dengan timeline yang hampir menyerupai sesungguhnya. Hal tersebut menggambarkan kondisi real yang terjadi di lapangan, sehingga ketika lulus, mahasiswa program studi teknik geologi akan terbiasa dengan bekerja multidisiplin. Program studi teknik geologi secara aktif melakukan seminar bulanan dengan topik yang beragam dari 8 bulan. Selain itu, program studi kami juga dengan aktif melakukan field trip paling 3 hari dalam satu semester. Hal tersebut dilakukan dengan tujuan memperlancar mahasiswa ketika mereka pergi ke lapangan.
Students of Universitas Pertamina, thank you so much for your guidance, thank you so much for your advice, for your motivation, semangat, sons. Well, I appreciate that so much and I will miss you guys.
I have a great time doing exchange students here because with the friends, the lecturers, and also the new environment for me is really welcoming. So yeah, I learned really a lot here.
Universitas Pertamina, be global leaders.
Ipin keluar ya dari Zoom sampai jam malam ini, sampai jam 3.
Okay, it seems like Mr. Zayan will take longer than expected, so we are gonna have a break for about 20 minutes. And in 20 minutes, all the participants are expected to be back in this room. Thank you very much. Okay, it seems like Mr. Zayan is ready. So we're gonna start the second session with Mr. Zayan with the topic of tackling environmental problems with GIS. To Mr. Zayan, please, the time is yours.
Thank you, Ratu. I will share my screen first. Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. In this morning, I will tell you about how GIS can solve the environmental problems. So before we start, let me introduce myself. My name is Muhammad Zainul Ahbani. Currently, work as a GIS engineer for education and community development at Esri Indonesia. On the other side, I joined Geohazard community as an instructor in some source course like Python course and machine learning using ArcGIS and bootcamp and other. Okay, maybe before we go to practice session, I will introduce you to some the fundamental of environmental problem and how GIS can solve the problem. Nowadays, we facing so many problem that we know it is occur in some nation. We know some loss of nature, and there are social injustice, weather pollution, and so on and so on. And so, how GIS can solve this problem, and we will discuss it about it. And nowadays we facing COVID-19 that so many made so many unemployment and other problems for our nature. Okay, so to overcoming the problem, we know that we have so many data that science can bring the I think bring good opportunity to make some changing or solve the problem. Okay. So using GIS, we can encourage so many people to see what other kinds of remote sensing data that we've processed with so many tools. We can see the real-time event, and we should go. We should go to the place that the event comes. So I think GIS so helpful to overcoming the environmental issues. So this is what we can provide using GIS. GIS is organizing the world geographic knowledge. So we can transform how we see the world or that we can see. So we know that this remote sensing data, you can download it or you can get from so many resources, so many websites, and you can download for free. For the remote sensing data, we can model it using GIS. This is I think this is our remote sensing data, and we can use GIS to modeling and to make a report, and we can tell our story, our report in a story map or other that we can tell other people. So how GIS can solve the environment problem? We start with measurement, where the measurement is relates to distance or the position. So we know that GIS is X and Y. You can draw some coordinate or position, and we know the location. Where is the location? So we can measure and make a visualization and mapping, and then make an analysis and modeling. For modeling, we know that what is the problem in some area or some location. So from the analysis and modeling, we can make a planning and design what we will do in the future. And from then we can make some decision making using GIS or statistical modeling that related to spatial data. And from that we can make some action that is relevant to our case study. So if GIS, we not using GIS to make some decision making or action, we will facing some problem, I think. So GIS have important position in the environmental problem. So GIS can integrating so many format of data. We know that nowadays we have so many data included unstructured data, and we know so many spatial data such as multidimensional data, big data, vector, imagery, lidar, or point cloud. So when we you know we we don't use GIS or we just using human hand, we can solve so many problems, or we can use this data. So we need technology, we need spatial to read some data and provide useful information. I think that is the importance of GIS to help people to visualize some unstructured data to useful information that all of people can read or can understand what you do. So because we will use our GIS platform or S3 product, I think I will introduce some platform that can connect to ArcGIS. So in this morning, we'll use ArcGIS Pro and ArcMap, whereas I will adding some tools like add-in mungkin maybe analytical hierarchy process, but we know that ArcGIS is an open platform that so many platform can be added to the ArcGIS, such as JavaScript or as Python, and we can use so many libraries such as GeoPandas, TensorFlow, PyTorch in ArcGIS platform. Yeah, maybe we can use also OSM and also GitHub to integrate in ArcGIS. So this is an open platform, not only a licensed platform, but it's I think it's so powerful to perform GIS analysis and modeling. So for this era or this decade, we know that data science is making some change to make some analysis is more easier than usual. So we know that nowadays we know machine learning and AI have so huge impacts to the easy ways to overcoming the issues. So many data or modeling we can integrate into in GIS, such as visualization, exploration, spatial analysis. We can integrate in in one platform using GIS. Maybe I think not only as reported, but yeah, GIS, some random GIS or other that related to GIS, we can use it to modeling. And then Esri provide us so many information that we can use for visualizing real-time data and analysis. In this PowerPoint, maybe I provide how ArcGIS can provide the real-time data, maybe using ArcGIS Online and other. Okay. Maybe if you see in the monitor, this is one of our products that we use to monitor the flood gate monitoring in Jakarta. This is a real-time data that can inform people that where is the place, is this dangerous, or we can see the legend that the status of the case normal, siaga, or other. And then we have hotspot analysis, hotspot monitoring. We know that Indonesia is so many events such as fire that happen in so many forests. So actually provide us useful information to monitoring the forest fire. So this is the powerful of GIS. And then we move to AI, machine learning, and deep learning. So we know that nowadays, so many people speak about artificial intelligence, machine learning, and deep learning. Actually, the AI, machine learning, and deep learning is come from statistician and mathematician, where they are developing the models to make some prediction in the business. But nowadays, the deep learning, especially artificial intelligence, is growing rapidly. So we can use AI to integrate with our GIS platform. So we can make some prediction, or we can some clustering classification, and then 3D object classification that we can provide so powerful information. Also, it is more easier, not easier, but it can make more. You can cut the time to process. You can process so many data in one time. With S report card, we have so many integrated data that we can use. Okay, ArcGIS Pro supports for notebook, like such as Jupyter Notebook, that in the environment of ArcGIS Pro, we can install some libraries such as Keras, Python, and other. But nowadays we not speak about the library or the programming, but we will speak about decision making for environmental problems. So this is one of the example how deep learning can how GIS work with deep learning. So you can see in the right side, this is a damage building classification. So we can count how many buildings that have damage or undamaged. So we can calculate how many building that damage, and maybe we can help the governments to solve how to solve more rapidly the problem in some areas. Okay, this is the example of weather potential prediction. We can predict various locations that have so many weather. So GIS not only for solving problem, but we can predict what potential in some areas. Okay, this is one of my research in several years later. This is the example of GIS for decision making, and the main ideas is for evaluation of spatial pattern. On the left side, we know that this is a evaluation of land capability. We have this data from very high until very low. So we use so many data such as geology, and then land use, and other data that we use such as using DEM to provide elevation, or so many data that we provide, and we use weighting parameter to provide this data, and we derive to become the direction of land use. So we have 5 legends of land use, like as forestry, and you can see in this legend we have so many legend data that we provide using spatial data. So, and on the right side, we know that this is the result of evaluation of spatial pattern. We produce this map from these two data. So we evaluated where is the suitable land use or unsuitable. Yeah, so it is very useful for the government, I think. So because Wonogiri is we maybe I think is facing so many problem in this area, so government should making decision. And this is one of my projects in before the establishment of New Yogyakarta International Airport. I've been working for modeling the inundation of tsunami, how long or how far the tsunami can affect the mainland before the establishment of New Yogyakarta Airport and after the New Yogyakarta International Airport was established. Okay, you can see in this in the left panel. This is before establishment of NYIA, and this is after the establishment of NYIA. So we can see that after the establishment of NYIA, the tsunami is more affects more. It's so far from the shore. So for this, we can decide what can we do to readjust the disaster of the risk of tsunami. So this is I have modeling some prediction or uh, some mitigation. Yeah, this is one of our project that we make some mitigation. We we make some model using artificial leaf. So we we make some barrier in front of the NGIA, such as this is planting mangrove. So we can planning. So we if we speak about GIS for planning, so this is one of the implementation. So we plan to planting the mangrove as artificial leaf. So the risk of the tsunami can reach us. Okay, and then I have some project about vulnerability mapping. So this is in Pangandaran. This is in some, maybe we can call it tombolo. In geography, we call it this is tombolo. So this is also vulnerable when there are facing a tsunami. So in maybe several years, Pangandaran facing a tsunami and some building was damaged. So this is physical vulnerability. It's it's coming from some data such as the number of roads and the building density and other. So we use analytical hierarchy process or decision making using statistical model to weight the factor of some factor. This is one of some parameter or some map that we produce, and then we have social vulnerability. the social vulnerability. Yeah, we know that this is the social condition in Pangandaran agency. And then we have economic vulnerability. We have add the data of minimum wage and then income and outcome every people in the areas. So mm, when we speak about the mapping unit, I use the building block. This is my mapping unit. Yes. So we have the data every block of every this block. So we use analytical hierarchy process to calculate it. So from this three map, we produce one map. This is uh, the, the total of vulnerability map using multi-criteria decision making. So in this log, it has three data. There is physical vulnerability, social vulnerability, and economic vulnerability. We use analytical hierarchy process, a statistical method to compute the data or the value of each data. So this is what we will learn in this day, or we will practice in this day. We will use analytical hierarchy process to landfill selection. So before we go to the ArcGIS Pro, maybe I will make sure that all of you have ArcGIS online account, or you already have some experience using ArcGIS Pro. So if you don't have any ArcGIS account, you can become a member of Learn ArcGIS using this link. You just click it. Okay. You can become a member of Learn ArcGIS organization. Just provide your name and your email. You just click your current position is you are a student or educator or a professional, and your age, and you just check it and click submit. Yeah, after you go to this link and you submit your application, you will uh, receive some notification, such like in this panel, an invitation to join our RGS online organization, Learn RGS. You just click this link and you will have RGIS for maybe such as personal use until the end of this December. So if all of you have RGIS or ArcMap license, you can follow this practice. Okay, before we go to the practice, I will tell you about the analytical hierarchy process. So you can get my data that I share to the organization. We have some data such as rivers, elevation, and maybe roads, slope, and other that we will use to perform analytical hierarchy process, also multi-criteria decision making. And every single parameter, they each have some weighted value that we can see in this panel, and subcriteria and buffer zone. So where the rivers is buffered around 0 to 1 kilometers, and the roads. This it has 0 to 3 kilometer to determine how many weight. So if you have my data in your computer or PC, you can open it to your ArcMap or ArcGIS Pro. But for the first, we will use ArcGIS Pro to perform the analysis. Okay, maybe I will introduce just some of HP application. So when you speak about analytical hierarchy process, you will input some data that as a numerical value, where one is equal importance to equal to moderate until this is a 9 extreme importance. So this is so important for you to know how to use analytical hierarchy process to weight your data. So HP is um, I think is semi-automatization, because we as a operator we should make a determine where is the most weighted value in the data. So it's not automatically, but it's semi-automatically. This is the example of the analytical hierarchy process table. So when A meet A, it is equal to 1, but A meet B, you can determine what parameter is more have impacts to the result that will you provide. So this is so many data that we will analysis, and you can use analytical hierarchy process to analyze the data. So I think it's more helpful to determine our maybe our planning using GIS and statistical models. Maybe before we go to the practical session, I will ask for, I don't know, maybe all of you have some question before we go to the practice session. Okay. Maybe if there's no question, we will go to the practice or practical session.
Okay. Is there any question, or maybe does anyone have a problem in installing this software before?
Maybe someone have a problem with installing the software, I can help you to install it. Okay. Is there any question or no?
If there isn't any question, maybe we can move on, Mr. Zayan, to the practice.
Thank you, Ratu.
Yes.
We can start this practice to open ArcGIS Pro. You can search ArcGIS Pro and topic. Okay. Uh, when we start ArcGIS Pro, we should make some project. You can click this map. You can rename the project, maybe ArcGIS. And you can change the directory of the project. You can save in other directory such as T or E or other that you want. Okay, because I have this project before, so I will open it. So if you have the project too, you just click it and reopen it. So it will appear that it is opening the project. Yeah, this is the data that I provide to the links. So this is the raster data, but I will start to the from vector data. So if you want to open the data, you just click drag and drop. Okay. You see the monitor. I have so many data. Uh, it is you just select the file data. This is so you just click uh, and then maybe we select the preferred data. Yeah, this is how to open the vector data or yeah supported format data. So ArcGIS supports some data such as file and then uh, JSON, GeoJSON, and maybe two package and other you can reopen. Maybe before we start, I will explain that we will need some license. So if you have a Learn ArcGIS account, you will have ArcGIS Pro name user license, and then some S3 extension. Uh, I recommend that you have minimum special analysis extension that because we will use spatial data, so special analysis. So I think you should have this extension. If you already check it, just go back and this data is buffer data, so maybe we will not start from scratch, so we will use the existing data, but maybe I will in, give you some overview how to make this data. So I have uh, road network data. uh, if you ask where I get this data, so maybe must have it already give the information that this data uh, it is come from Inagio portal. You can download it for free. You can download so many data such as vector data or imagery data such as DEM, digital elevation model. Okay. ArcGIS Pro have some geoprocessing tools that we can see in analysis tab. This you can click tools. You can search for buffer. This is the buffer for the single buffer, and this is for multiple ring buffer. If you use buffer, normal buffer, you you will have this is data. You can add the distance or of the buffer data, and you can determine where is you can save the data. This is the default. The default is in your Geo database. So if you want to see your Geo database, you can see. You can go to the View tab. You can click the Catalog view. This is the database that you have already. If you don't change the directory, the data will automatically save in this directory. You can see in this directory. So we will use the default directory. Okay. Oh no, maybe I will change the directory. This desktop, you'll see street buffer. Click save. This is the format data automatically save to save file. This is you can change the unit. You can use kilometers or meter or decimeter or so on or so on. We will use meter. Maybe I will give 500 meters. And then you can see this is a cell type, full, left, right, or explode. Yeah, I will use full. And then the type, this is round or flat. This is the will affect the outer of the buffer. And then we have method, geocastic or planar, and dissolve. We no dissolve. This is the output coordinate system. If we don't we have no input, or we just this our default. Yeah, I think in this environment you use defaults rather than customize. So you just click run. Yeah, this is the buffer is complete. You can see in this map. Now this is the example of buffer data that we use run time. So if we use flat in this alter, we will the feature was flat. We will go to multiple ring buffer. You can try it as you like for use buffer, and I will introduce to multiple ring buffer. For the multiple ring buffer, we have input street. We will save in, maybe we will try to save in default to database. The distance we add 100. This is for 100 and 600. Yeah, we can add some distance if we use multiple ring buffer. We can determine the distance unit. We will use meter or matrix, and we will provide some information, or we add some field in our set file. So we will rename its buffer distance. This is dissolve option. We use non-overlapping. We try just click run. Yeah. You can see the difference of multi-pairing buffer and the normal buffer. The multi-pairing buffer give us some data that this is multiple data. If the normal buffer it just provide one buffer data, so the multi-pairing buffer have so many distance. This is the 200 meter from the roads, and this is 4000, and the other is 600. You can try it as you want to change the parameter such as the soft option. You can see the output feature class. Yes, you can see the database that the feature class is already saved in the default database. You can change the directory. I will use my existing folder. Okay, we will adding some distance, and we'll modify the distance. Distance unit is meter, and the dissolve option we use overlapping, and the environment was default same as the input, and then just click run. We will see the difference of this dissolve option. Yeah, we if we select the overlapping, so the data was like this. So many overlapping data in the intersection. So this is the intersection of roads. So yeah, this is I think better than the non overlapping visualize it. Okay, if you already have this data, you can see in the attribute table. We have some buffer distance that we have to give the value. So in this course, I've already have the value to rating the buffer distance. So this is a sub-criteria and buffer zone. We will use it to add the value in this attribute table. So this is the rating value that we will use to give the value. Or we just maybe using modified value that we here as we like. You just click add field, and then you will go to this field. You just give value and the data type. Sorry, data type was long, and after that you can alias rating value. Just after that, click save. And you will have the rating value in this side or this attribute data. So we will add some value in this in this attribute based on this writing value, but maybe I will modify it. Where is 0 to 1 kilometer is 200. This is I will give 7 values, and then for 400 is 10, and then the second row is 3 years. So select this. Now, if you already modify, you just click save again. Yes, click this on the right panel. Save edit. Okay. So from this we will generate raster data because the analytical hierarchy process and weighted processing will use raster data. So we will use rasterize. You can see that this is polygon to raster. We have so many conversion tools such as polyline to raster, vector to raster, point to raster that we can use to rasterize the data. If we use polygon to raster, we will input our data. Don't forget to change the value fields to buffer distance, or I'm sorry, we will use writing value because the raster data will have one data that is a raster value. For the output, we can use this default code database, or you can move to existing folder that you have. You can rename it. And then click save. Oh, I'm sorry. Oh, just three. And this tools is cell assignment type. We will use cell center, and the priority fields is rating value, and we can determine the cell size. Nah, the cell size so same for one and another parameter. So we have so many parameters. So we will use 12.5 for the cell size. So if you make raster data for other data such as village and river, the cell size holds 12.5. And the environment is defaults as this, and then you can click run. Is waiting for a while. I think you just wait because this is already running the data. So if we do other thing, it will crash. So this is the result. You can see this is the street. This is the distance from I think 200. This is the value is 3 and 7 and 10. This data will use to weighted each parameter. So if you already reach this step, you will go to weighted steps. Sorry. So we will use the existing data that L provides. The organization can help you to open the data or provide the data. So we have so many data such as roads, river, slope, urban, village, elevation. So this is the distance. The road have the value 0 to 10, and the river 0 to 1. Slopes 4 to 10 is like the example of the paper. So this is come from some research. So I use this for to determine the value of my parameter. I have urban, village, elevation, and land use. We will go to vector parameter, okay, vector sum. So in ArcGIS Pro we have so many vector tools such as vector sum, vector overlay, and graphic vector vector. So we will use vector sum to calculate its parameter. So we just need to add this parameter such as roads, the field, this value, the default fields that so raster just have one field. So this is the field is value. We will provide the weights. Maybe I think I will give 3, and then river I will give some as road 3, and I'll add in the slope. I'll give 4 maybe, and I have urban. Maybe the urban is more important than others, so I will give 5. And then the village. The selection for a landfill is more important than the land that is more far away from village. We just add all of the raster data to these fields, and we will calculate it. Okay, just click run. So this is the output is in the default Geo database. Click run. So this is the results. You can see for the data, you can change the symbology. Can change to this color, or if you have so many too many noise in this data, you will change this weighted value. But I think for the weighted value results equal to 1, so the sum is equal to 1. So this we have 1, 2, 3, 4, 5, 6, 7 value. So we should provide data that equal to 1 for the better legend. So this is the legend is to overrated, I think. So this is 0.1 and 0.1, and this is 0.2, and the urban is 0.3 for the field, so 0.3, fashion 0.1, and the land is 0.2. Three. maybe this is good enough. Data. So for this weighted sum, we as operator have a huge impact to the results. So this is non-automatically. It is just we summarize each parameter. So maybe we will go to the example of this research. So I refer over this research for landfill site selection using the decision making methods in Iraq. So this project is based on the research for landfill site selection. So this is the data that I think it's more simple data. The range is from 1 to 14. So it's more compatible rather than this data. So because the range is from 33 until 44. So this is a result from weighted sum. We will go to analytical hierarchy process. I will introduce some ArcGIS add-in for. So I will provide. Okay, if you have to install the analytical hierarchy process that I provide for you for the link that I have shared, so you can go to add-in manager. If the analytical hierarchy process already installed in your ArcGIS Pro, in this add-in you will see the AHP add-in for ArcGIS Pro. The analytical hierarchy process add-in for ArcGIS Pro was developed by Rohit Venkat Kandi Mendala, and you can see the add-in in this tab, add-in tab. Now you can see analytical hierarchy process, the decision analysis tools. You can click it. Okay, maybe before we start, we will see this report. So analytical hierarchy process add-in for ArcGIS Pro developed by Rohit Venkat Kandi, inspired by Oswald Marioni extension for ArcMap. So before the developing of AHP in ArcGIS Pro, analytical hierarchy process was provided in ArcMap. So in this ArcGIS Pro, the analytical hierarchy process add-in is the developing from the existing analytical process. So I think it's not stable. So maybe we will use analytical process in ArcMap because already try this analytical process in ArcGIS Pro, but it's can't work. But maybe we can just see how uh, to running this AHP in ArcGIS Pro. Where you just click to add a raster to selected criteria, slope, urban, village, and elevation and land use. And then you just click add selected criteria for AHP analysis metric. Now you can see this table. Yeah, so you will give the value of each table, maybe example roads and river. Uh, is the road is more important than river? If not, you can see this is enter value between 1 equal preference and 9 very strong preference. So if you can click 1 is equal preference and the approach and slope, maybe I can see maybe 3. So is 1, village is 3, and land use, okay, so is 2. You can give the data as you like, but you have consistency ratio in this model. So the consistency ratio should be lower than 0.1. So the consistency ratio is the ratio that each parameter have consistency. So yeah, this is the variable control. maybe we can just give a random value. We can see how this ArcGIS Pro AHP will perform this data. Okay, and if you already give its pairwise comparison, so this is table of pairwise comparison table. So each parameter will be pairing each parameter and have each value, each other. So we can just calculate it. So this is it is notified that consistency ratio is 0.28. Please revise your ratings in order to obtain consistency ratio less than or equal to 0.1. So the consistency ratio should equal to 0.1. If you don't revise your data, you cannot running this model. So I think for the ArcGIS Pro, it's too hard to running this model. So we will use ArcMap to running the analytical hierarchy process, because in Snake I'll try this and it's have the bad results. So just we will move to ArcMap. For your information, ArcMap, the latest version of ArcMap is 10.8, and the developer is moved to develop ArcGIS Pro. So this was the latest version of ArcMap. So if you don't have the extension, I will share you the link to download the extension. You can click this link to download the extension. As you have to see the monitor, this is the ArcMap as 10.7. You just have to make the blank page, click cancel, and you can see that if you already have analytical hierarchy process extension, you will have in this HP, in this tab. Before we go to HP, make sure that you have special analysis extension. So you just click customize and then go to extension. You have to click the special analysis. Make sure that it's already checked and then click close. To add some add-in, you just need to customize it. You can search. If you already downloaded the analytical process, you will see the AHP in this tab. So you just click and drag in this section. AHP and click close. Yeah, this is same like ArcGIS Pro. So this is the first release of analytical process before the developer moved to ArcGIS Pro. So yeah, this is. You can go to the raster data. You just drag my data in this tab. in the table of content, just click drag and drop. This data seems like the ArcGIS Pro have. We have roads and another. You just click the analytical process add in, and you just click road slope and then slope. You just add all of them. Click and yeah, you have the data in hierarchy process. So this is hierarchy criteria that we will execute in this hierarchy process. So click next. We have the same model for the ArcGIS Pro. We have a slope in our maybe we will give the value to each parameter. Yeah, so I have the better data, so the consistency ratio was equal to 0.1. Wait. So you can see in my monitor, this is the data or the compute data that the consistency ratio is lower than 0.1. Do you just add to this table where road and slope is 5 and slope road and urban is 3, field is 3, elevation is 6, and for the road and land use was 7, and road and river was 5. For the slope, slope and urban was 2, and slope for slope and village was 5, for land use 3, or you can try to add in the data. You will randomly, I will randomly be for the fastest processing. Okay, you just compute. Sorry. Yeah, you can see that the consistency ratio was 0.2, but in this ArcMap, whatever in the consistency ratio, it can be running. So just make sure that you check this create file. You just create map. You save as save. And then it will prompt and generate it for the data. So and then click finish. You will see this is the result of analytical hierarchy process. So the value was 0.9 until 16. So the I think the green one is the more suitable place, and the red one is the non-suitable place, because you know that this is more close in the for the urban and close for the river, close enough for the roads and other. So I think the landfill selection is one of the application of location intelligence. So nowadays we know that location intelligence is make some change to industry to determine where is they will develop their or to expand to make expansion for the industry. So yeah, this is not only for suitable analysis, but it's can for the location intelligence for developing some yes, landfill. Maybe Ratu, it's enough for me. Uh, I will maybe if there are any some question.
Yes, for the participants, if you have any questions, feel free to write them down in the chat box. Okay, Mr. Zayan, we have a question from Fahri. What is the difference between weighted sum and weighted overlay? When can we use weighted overlay and when can we use weighted sum? Thank you.
Okay, thank you for the question. Now we will practice the tools. So this is we have weighted sum. We know that we already performed the weighted sum, and this is a vector overlay. So this is a vector overlay several raster using a combination scale and weight its according its importance. Yeah. So for the information, we know that this is difference based on the importance. So I already try to use a vector overlay. We can add the data. So the vector overlay needs to integrate data. So when we will use, we can use anytime we want. I think, but vector overlay is such as like overlay its data. So if you have a vector data, you just overlay its data and produce some maps. And the vector sum, it's sum. It's the data every data that have intersects data. This is more the different concept, I think, but the result is also different. You can try if you want to provide the data using integer type because it can work better in ArcGIS Pro. But I think it's good enough if you can run this weighted overlay. So you can see this is a sum of influence. Yeah, should be 100. So the weighted is controlled by us. So the value should be 100. Yeah, maybe it's from. Is there any question?
Okay, Fahri, does that answer your question or do you have any further question? Okay, it's enough. Thank you, Mr. Zayan. And do we have any other question?
Yeah, if there are any question, let me know. maybe I will give you some information. Wait. Okay, if you want to download the analytical hierarchy process tools, you can download it from this link, and you can just click download and install. So I think it's work in ArcGIS 10.1 and 10.0. So for the ArcGIS 10.3 and the latest version, I think it's not supported by these tools, but you can search in another resource, or maybe I can share you my extension. But yeah, better I will share you my extension. Okay, is there any question?
Yes, Mr. Jayan, there is a question from Rivaldi. Rivaldi asks, how to make a validation without doing ground check? Is GIS data dependable? Thank you.
Okay, thank you for the question, Rinaldi. Uh, I think we should check for the ground truth, because the GIS is for data modeling, not for data uh, data checking. Or I think it's going for rapidly, but when we make some analytics or analysis or modeling, we should checks to the directly to the field, and should have ground checking for the better and accurate data. Maybe if you uh, using machine learning or deep learning, it's better that you should check. You should do ground checking. Maybe it's from me.
Okay. Rivaldi, do you have any further question? Or does that answer your question? Okay, we'll move on to the next question. It's from Firman. Firman asks about inconsistency ratio. What does inconsistency ratio means? Is there any limitation of inconsistency ratio value so that the AHP method can still be used?
Okay, thank you, Firman. Maybe did you mean consistency ratio? So in AHP, we talk about consistency ratio. There is no inconsistency ratio. For the consistency ratio, it's limited to 0.1 that we see in this data. Okay, we will add this data. Okay, and then we can compute. Maybe we can add some data in this table. You can compute uh, uh, for the for the consistency ratio uh, from Thomas Saadi. So Thomas Saadi is one of person who developed analytical hierarchy process. He said that the consistency ratio is limited to 0.1. For the better or accurate data is 0.1. When the data is higher uh, from 0.1, the data should be not accurate or not consistent. So I think, yeah, maybe it's enough for me.
Okay, Firman, does that answer your question? Okay, that's enough. Thank you, Mr. Zayan. And we have another question from Fania, but it is a little out of the topic that we talk about. The question is about interpolation method in ArcGIS. I often use spline, IDW, topoto raster, etc. But I haven't know what is the difference between each other interpolation method. Which is better? How do I choose the one method besides my data? Thank you, sir.
Okay, thank you for the question. So, several times I use ETW inverse distance weighted and then topo to raster. So if you ask me how I chose the method, so it depends on what will you provide the data. So inverse distance weighting factor is this tool is interpolate based on the distance its point. So if you have point one to another, we see if we imagine that this is point and we have the point more closely, and the difference of this point, maybe this is have z value, this is 8 and this is 9. So the ETB will interpolate the value based on the neighbor or the more close value. And when you say topo to raster, I'm sorry, topo, topo to raster, right? I'm sorry, Datu, is that topo to raster or what?
Yeah, topoto raster.
For the topo to raster, I think this is for topographic to raster, and the input was polyline, I think, but topo to raster is generate data, interpolate the data, um, and process them. But the data is based on uh, different is maybe I think the interpolation method. There is a type point elevation. You can see the contour, stream, sink, boundary, and other. So the input of the topo raster was so uh, have a variance type, but yeah, usually I use the contour data to generate DEM. So yeah, I said it depends on what will data you provide. But I prefer if you have contour data, I will prefer you use topo to raster. But if you have point data or spot edge, you better using inverse distance weighting factor. Maybe it's for me.
Okay, Miss Fania, does that answer your question, or do you have any further questions? Okay. Fania asked again, how about spline, sir?
Oh, spline, wait. Spline. I'm rarely using spline, but I will explain you some overview of the spline. The spline is using a three-dimensional minimum factor. So the spline is same as inverse distance weighted. They use a get value, but the difference is in spline type. You can write in this information. Okay. So there is some parameter like Bayes number of point that will you interpolate. So the number of point per region. So if you uh, have this point 12 point, the spline will interpolate 12 points to make a restore data. But the inverse distance weighting, it's just depend on the the more closely point that you have. Yeah, maybe it is for me, Lina. So it just from the the difference is in the parameter that you have. Is there any question?
Uh, yes, there is another question by one of the participants. He asked how to link GIS result with web application.
Oh, I'm sorry.
He asked how to link GIS result with web application.
Okay. So if you have the data, so I think for the web map, we will provide in vector data. So I will open my vector data. So if you have a vector data or raster data, you just click on the right click on the mouse and you click on the sharing data. This is you have some option save as layer file or save as layer package, share as web layer or offer web layer. You just click share as web layer. Or you can click on the tab share in this panel. You can see so we will share as web map or web layer or this web layer or web views. So you can share using share tab and you just give summary. Maybe this is a vector data. You provide text and then you so choose the layer type. This is a feature tile or vector tile. I prefer that you choose the feature because when you will develop in web map, you will use feature rather than tile or vector tile. Or your location. If you have a ArcGIS online account, so you will integrate to your folder. So the folder in your ArcGIS online is such like this. You just select one of them and then click for the share. You better you click the everyone so everyone can see your project, or you can you have the group you will share. Where is the group that you will share, and you just click analyze or directly to publish, but I prefer to use analyze to see what is the error in your data. So you can publish it. Yeah, after there is no error, it just some uh, yeah warning, but you can publish it. Click publish for share one feature layer or vector data, but you can share using web map. If you choose the web map, you will share all of the layer that in this table of content to your ArcGIS online. So this all of data will upload it to your ArcGIS online account. So the summary might be, I'm sorry, GIS for environmental text, maybe analysis. Nah, you will select this is copy all data exploited or editable or visualization. When you select the editable, you will able to edit in your ArcGIS online. Where if you choose the exploratory, so there is interactive map. supporting for query. So you can query your data in ArcGIS Online, or you just use visualization for fast rendering, just for visualization only. And the folder, you just select where is the folder you will save and check, and you just click analyze, because some data maybe have some error, so you should analyze the data. Yeah, there is one error there, where is the surface layer has different projects in that the map projection. So if you want to publish in web map, you should to convert the projection into one projection. I prefer you reproject your map to wait. You will use so this is VQS. Uh, you will use. I'm sorry. I prefer you use World Geodetic System 1984 Web Mercator for Web GIS or ArcGIS online application. So you will convert all of your data into this uh, coordinate system. Maybe it's enough for me.
Okay, thank you, Mr. Zaya. And we have another question. It's from Mr. Henki Purwonegoro. Mr. Henki asks how to create criteria range and determine the weight scale in GIS modeling. Thank you.
Criteria range and determine weight scale in GIS modeling. To create a range and determine weight scale in GIS modeling, it's depend what you see in the field. So before you practice GIS modeling or GIS analysis for weighting, you should check you should do ground checking before you can weight each other. So the ground checking is more important thing when uh, before you go to the modeling. So what you see is what you model. So it will be more accurately for the modeling when when you when you do ground checking rather than not perform ground checking. For the weighting scale, I think it's 0 to 1. It's more better because you can see in the table of content the range of the value will show will have so many bigger data. So I think prefer that the weight is 0 to from the range 0 to 1. Yeah, I think it's enough, Ratu.
Okay, Mr. Henki, does that answer your question, or do you have any further question regarding your last question? Okay, that's enough, Mr. Zayan. Thank you. We have another question from one of the participants. Can the results of the GIS be used by the community to solve problems or take an advantage of a policy?
Um, for the community, yes, it's maybe. I'm sorry. Maybe you can read again the question.
Okay. Can the results of the GIS be used by the community to solve problems or take advantage of a policy?
Yes, yes, it can. Yeah, so when we talk about the multi-criteria decision making, you will have one results that it will use for the policy making. So I have some research that relate to policy for the policy making like this. So this is wait, like this. This is for vulnerability mapping that uh, we have to share with the under governmental. So the governmental have the policy to overcome the situation of the tsunami or the vulnerability mapping. Also, maybe this one. This is in the for the vulnerability vacancy. We give some um, yeah, we serve to the governmental, so the government should have the policy making. So so many governmental institutions using GIS uh, to to make the planning for the you know rencana tata ruang. If you know that is the GIS, how GIS to help the governmental to make a policy for the environmental problem. Yes, maybe that's the answer for me.
Okay, thank you, Mr. Zayan. And we have another question. It's how accurate does a GIS analysis handle environmental issues?
Okay, thank you for the question. Yeah, it's so interesting. So when we discuss or we talk about environmental and accuracy, so we back to where what is data that you have, where is data come from, and yeah, you should to make a ground checking to have more accurate data. So for my experience, it's it's has better accurate if you make a ground checking and use several references that it's uh, yeah, you know, maybe in a Q portal, one of the example, it's a more accurate data that it can be used publicly in your organization or uh, the government. Maybe yeah, it's enough from me, Ratu.
Okay, another question. Can you demonstrate how to download an Esri product like ArcGIS Pro? And
Mm.
also, ArcGIS is it available? Is it available for free? Because the Esri software is certainly very powerful. Thank you, sir.
Okay. Thank you for your question. Maybe I will give demonstration how to download it. So you should have the firstly you should have a personal use account, or you can use your RGS account, and you should go to mysri.com, or I think you just can write RGIS Pro download. You will find this is download, install and authorize ArcGIS Pro documentation. You just click it. Or if you have my Esri account or personal use license, you just go to my organization and this you will see download. So better that you have personal use account to download all of S3 products like ArcGIS Pro, ArcGIS Desktop, and then ArcGIS Lesson Manager, and you can see so many resources that you can download it if you have a personal use account. We have ArcGIS Desktop, every each person, and you can request to our technical support what will you download. Yeah, if you yeah maybe if you search for artist portal, yeah, you will be go to my S3 same like this. maybe it's for the first question and the second question. What is it, Ratu?
The second question is ArcGIS is available for free because the S3 software is certainly very powerful.
Okay. If you want to free account, you can use Learn ArcGIS. It is trial until the end of this year. So you can use ArcGIS personal use for free until this 31 December. You can use all of ArcGIS resource. Uh, if you want to have personal use, maybe you can buy from our business partner. But if you want to free account, yeah, you just use is Learn ArcGIS. Yeah, maybe it's enough from me.
Okay, thank you, Mr. Zayan. Do we have another question? Okay, if there, okay, okay, there, maybe this is gonna be the last question for today's session, sir. The question is, uh, it's out of topic, but how can we join the Geo software community?
Okay, there is maybe out of my capability to answer this question, but maybe I will try it. If you want to join Geohazard community, maybe yeah, yeah, I don't know how to join Geohazard community, but just contributes for the developing of our geospatial information. You just maybe, yeah, maybe you can contact Mas Adit for join to if you want, if you interest with Geosphere community, you can contact Mas Adit or Mas Hafid because maybe both of them is founder and co-founder of Geosphere community. Maybe yeah, it's just what can I answer.
Okay, maybe before we begin, we end the session. Okay, there is another question. Could you please share the slides? Can we?
Wait, I think I already shared the slide in my OneDrive that I share with you, or maybe your
Okay,
teams, Ratu.
yes, maybe our crew will share the link to the slides later. And before we end this session, maybe do you have anything to say to the participants for this session, sir?
Uh, maybe it's enough because this maybe is 11:30. It's
Okay.
time to have break.
Okay. Thank you so much, Mr. Dayan, for the useful presentation. So maybe I will conclude what Mr. Zayan talked about. So from Mr. Zayan, we learned that GIS is a very powerful tool. We can make and show to others real data in real time so people can be informed as quick as possible. And GIS also can be used for evaluating areas so we can make a risk management or risk reduction map. And as for this session, we use AHP or analytical hierarchy process to analyze which parameter that affects most to one area or case. Okay, maybe that will conclude our session. And before we end the session, maybe I could ask all the participants to turn on your camera because we are going to take a photo for documentation.
Please turn on your camera so we can take documentation. Thank you. In my laptop, there is 5 slides, so I'll personally ask you to stay until I say it done for a couple of minutes. So 3, 2, 1, cheese. Three, two, one, cheese. Three, two, one, cheese. Three, two, one, cheese. Okay, that's it for the photo session.
Okay, and before we move on to the third workshop for today, we are gonna have a break for until 1 o'clock. So the participants can either stay here in the room or can leave, but we expect you to be here at 1 o'clock. Thank you very much. Good afternoon, everyone. I'd like to remind you that the third workshop will start in 5 minutes. I hope you all had a nice break. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Before we begin our third workshop for the day, I would like to welcome our third speaker, Mr. Ahmad Fadila. Sir, welcome. And I would also like to all the participants, welcome back. I hope you all had a nice break. So without any further ado, Mr. Ahmad Fadila will start the workshop with the topic of modeling hydrogeological contamination using mode flow. To Mr. Ahmad Fadila, please, the time is yours. I'm sorry, sir, you're still muted.
Oke, terima kasih MC. Is there okay if I use bahasa for this presentation because my English is not well enough. I'm afraid I'll deliver the materials a bit. And I see the participant mostly is from Indonesia. Is there okay?
Yes, sir, please. It's
Oke,
okay.
terima kasih. Mungkin agak campur-campur sedikit kali ya, karena slide-nya juga dalam bahasa Inggris kok. Terima kasih MC Mbak Ratu. Izin saya untuk share, udah bisa belum ya? Share. Oke, apakah sudah terlihat?
Terlihat, Pak.
Ya, baik. Selamat siang semuanya, Bapak, Ibu, dan rekan-rekan peserta. Ini kalau boleh tahu pesertanya, background-nya kira-kira apa aja ya? Boleh sedikit dijelaskan nggak? Karena tadi saya dari pagi nggak ikut karena ada kegiatan. Apakah semuanya mahasiswa atau ada praktisi juga?
Kebanyakan sih praktisi, Pak.
Oke. Sip. Kalau gitu sebelum mulai boleh saya minta sedikit, saya ada sedikit survei atau request gitu ya, sedikit aja nggak banyak buat peserta untuk meminta inputan bagaimana sih pengetahuan awal mengenai topik yang akan saya sampaikan gitu ya. Ini akan saya share di kolom chat. Oke, silakan untuk para peserta untuk mengisi form yang ada di kolom chat. Mohon sebentar untuk mengisi sebelum kita mulai sambil saya pengen tahu inputan para peserta ini seperti apa. Terima kasih. Oke, kembali ke slide. Jadi tema yang diberikan ke saya itu mengenai modeling hydrogeological contamination menggunakan mode flow. Sebelum kita masuk, saya perkenalkan dulu. Nama saya Rahmat Fadilah, biasa dipanggil Fadil. Saya sekarang bekerja di program studi teknik pertambangan Institut Teknologi Sumatera. Posisi kampusnya ada di Lampung, Provinsi Lampung, tepatnya di Lampung Selatan. Kemudian keilmuan saya kebetulan di hidrogeologi tambang, karena saya S1 di teknik pertambangan, kemudian saya melanjutkan studi S2 di teknik air tanah atau hidrogeologi. Kebetulan saya juga diundang sama alumni dari teknik air tanah juga, Pak Husna dari Geosoftware Community. Terima kasih juga buat Geosoftware Community yang sudah mengundang saya untuk sedikit berbagi ilmu tentang topik yang mudah-mudahan bisa bermanfaat buat para peserta semua. Oke, ini ada kontak email dan ponsel saya. Silahkan kalau nanti ada yang perlu didiskusikan lebih lanjut, karena waktu 2 jam ini saya rasa kurang gitu ya untuk mengupas tuntas topik yang ini. Jadi kalau ada nanti apapun tentang topik ini atau yang berkaitan dengan topik ini yang ingin diskusikan, atau mungkin di tempat Bapak Ibu sekalian punya ada yang ingin diteliti mengenai topik tersebut bisa kita diskusikan bareng-bareng. Oke, itu sedikit perkenalan dari saya. Nah, kemudian untuk agenda workshop kali ini, yang pertama saya bagi 4 agenda. Pertama, introduction. Ini sedikit membahas mengenai air dan air tanah secara umum, in general. Kemudian di second agenda kita masuk ke sedikit mengenai groundwater contamination. Kemudian yang agenda ketiga modeling dengan mode flow. Kemudian kita kalau sempat insya Allah kita akan exercise sedikit dengan simple case menggunakan mode flow sebelumnya karena sedikit saya kasih sedikit informasi. Mode flow itu sebenarnya hanya bahasa pemrograman. Nah, kemudian untuk merunning itu banyak aplikasi yang bisa kita gunakan. Nah, karena itu tergantung usernya. Karena dari dulu, dari saya mulai belajar mode flow itu saya terbiasa dengan visual mode flow. Jadi untuk nanti exercise-nya saya akan menggunakan visual mode flow. Tapi sebenarnya banyak aplikasi lain yang berbayar maupun free itu bisa di-download untuk operasi mode flow ini. Untuk yang visual mode flow ini kebetulan dia aplikasi yang berbayar, jadi cuman kita bisa download trialnya dan kita bisa coba. Untuk hari ini silahkan, ini saya kasih lagi link untuk bisa mendownload trialnya, silahkan, atau mungkin ada yang udah mendownload sepertinya ya. Itu udah saya berikan linknya untuk mendownload aplikasi visual mode flow-nya. Oke, saya lanjut ya. Mohon maaf nih, saya rada gugup sebenarnya ini. Pertama kali saya memberikan materi, ngasih workshop gitu ya, secara virtual dengan peserta yang umum. Biasanya saya ngasih kuliah ke mahasiswa. Ini pasti kalau dari praktisi ilmunya pasti lebih banyak dari saya. Jadi kalau misalnya ada yang kurang, kalau misalnya ada yang mau ditanyakan silakan disela aja selama presentasi ini. Seperti itu. Kemudian saya lanjut ke, untuk goals-nya, karena di waktu yang singkat ini, goals kita hari ini hanya to understand basic concept of groundwater contamination. Kemudian yang kedua, kita membuat simple case groundwater contamination model using mode flow. Jadi kita nggak perlu prepare data, kita langsung aja gunakan softwarenya, kita bikin model yang simple, yang mudah dibuat, agar paling tidak apa saja yang dibutuhkan untuk modeling ini bisa kita pahami gitu ya. Sebelum nanti kalau misalnya mungkin udah simple case-nya kita udah bisa, kalau nanti punya data yang lebih kompleks bisa lebih dipelajari lagi. Cuman mungkin nggak di workshop ini gitu ya. Oke, kemudian kita masuk ke introduction. Nah, yang selalu ada ketika kita bicara tentang air, mau air tanah, air permukaan, groundwater atau surface water, kita tidak bisa lepas dari water cycle ini. di mana air itu kita nggak tahu startnya ini di mana, ini ibarat telur sama ayam, yang duluan yang mana. Cuman ini adalah sebuah siklus. Kalau misalnya kita tinjau dari laut awalnya, si laut itu teruapkan, terevaporasi, kemudian terevaporasi menjadi awan, maju ke daratan, atmosfer, kemudian terkondensasi menjadi hujan, turun menjadi hujan, bisa juga sampai ke turun menjadi hujan, ada yang menjadi runoff, ada juga yang menjadi infiltrasi ke dalam permukaan tanah. Nah, yang infiltrasi itu ada yang nanti langsung menjadi seepage atau keluar menjadi mata air, kemudian dari mata air itu menjadi sungai, kemudian masuk ke badan air yang seperti danau ini, terevaporasi dari sini juga bisa. Kemudian ada juga yang menjadi groundwater storage, air tanah. Nah, ini yang menjadi yang masuk ke dalam aquifer tadi, yang menjadi cadangan air tanah. Nanti sampai dari freshwater ini mengalir terus sampai kembali lagi ke laut. Begitu juga groundwater ini ada yang berinteraksi dengan air laut. Begitu seterusnya siklus ini dari ice juga, dari gunung es itu, dari glacier, kemudian mencair juga bisa menjadi runoff, mengikuti siklus-siklus yang ada di sini. Jadi kira-kira seperti itu. Jadi sebenarnya air itu jumlahnya itu aja. Cuman yang berbeda adalah ketika dalam proses ini ada gangguan apa di sekitarnya. Kalau misalnya ada pemukiman, berarti ada gangguan penarikan. Artinya air tanah kita ambil, kemudian kita buang menjadi limbah gitu ya. Kemudian misalnya di sungai ada kontaminasi dari industri atau kegiatan pertanian dan perkebunan, macam-macam itu juga bisa merubah kualitasnya nanti. Ini sedikit mengenai siklus air. Nah, kemudian keberadaan air sendiri, karena 70% lebih lah bumi kita ini adalah akan air gitu ya. Di mana dari 70% itu sisanya daratan gitu ya. Di mana dari 70% itu 96%-nya itu adalah air asin atau air laut. Nah, kemudian freshwater atau air tawar yang bisa yang biasa kita konsumsi itu ternyata hanya 2,5% dari total jumlah air yang ada di bumi. Nah, dari 2,5% itu 68, hampir 70%-nya adalah air dari glasier atau air dari es, gunung es. Sisanya dari groundwater ada sekitar 30%, dan lain-lain surface freshwater, air bersih yang ada di permukaan itu hanya 1,2%. Dan kalau kita bagi lagi, ini ada pembagiannya lagi dari danau, kemudian sungai, dan lain-lain. Soil moisture, atmosfer, nah itu termasuk di surface dan under freshwater. Kelembaban tanah juga. Nah, jadi sebenarnya cadangan air kita itu ya hanya 2,5%. Tapi insya Allah kalau kita pakainya konservasinya bagus, ini akan cukup. Karena kan dia cycle, pasti akan terus ada. Tergantung gimana kita memanage-nya. Nah, itu sedikit introduction mengenai air dan air tanah khususnya. Nah, kemudian kita masuk sedikit ke groundwater contamination. Apa sih sumber-sumber dari groundwater contamination itu? Kalau menurut Vetter dari bukunya Kontaminan dan Geology ada 6 kelas sumber dari groundwater contamination. Yang pertama, source yang didesain untuk mendischarge atau membuang suatu substance atau material atau komponen gitu ya. Contohnya ini satu, hasil buangan limbah rumah tangga atau septic tank gitu ya. Nah biasanya kan septic tank itu ada di di bawah di atas muka air tanah gitu ya. Dan ini fungsinya kan emang untuk membuang hasil limbah dari rumah tangga, hasil limbah kita lah, limbah manusia. Nah ini satu sumber kontaminasi. Kemudian yang kedua itu sumber yang didesain untuk store, treat, or dispose substance. Contohnya landfill. Nah, landfill itu kan sebenarnya untuk tempat TPA lah kalau kita lihat. Itu kan dia untuk menyimpan sebuah limbah gitu ya di daerah tertentu. Nah ini juga bisa, harusnya ini kan di daerah remote dan disimpan dengan manajemen atau lapisan yang bisa menghindari source. Cuman di sini banyak terkadang adanya licin atau rembesan kontaminan yang masuk ke air tanah. Kemudian yang ketiga yang didesain untuk meretain substance saat transport, misalnya tumpahan material dari yang tidak sengaja jatuh ke permukaan, tumpahan poli atau material hasil tambang dan sejenisnya yang jatuh atau tumpah ke tanah, itu juga bisa jadi sumber ketika ditransport gitu kan, ada getaran, bisa juga dia kecelakaan, bisa jadi menimbulkan adanya kontaminasi. Kemudian discharging substance as consequences of other plant activities. Misalnya dari yang nomor 4 ini, dari kegiatan pertanian atau perkebunan, misalnya pakai pestisida, kemudian rembesan dari jalan, dari material jalan ini yang merembes ke dalam permukaan tanah. Nah ini dari kegiatan ini yang sebenarnya aktivitasnya lain, ini bisa menyebabkan kontaminasi juga. Kemudian providing a conduit for contaminated water to enter aquifers, ini contohnya misal ada lubang bor bekas pemboran oil, ini contohnya yang sudah abandon atau yang sudah tidak terpakai. Nah ini ketika karena pipa ini kan tidak mungkin satu segmen langsung, tidak ada pembatasnya, pasti ada sambungan-sambungan. Nah dari sambungan-sambungan ini memungkinkan adanya kontaminasi yang masuk ke dalam sistem aquifer freshwater dari yang kalau misalnya tidak termanage dengan baik. Kemudian selain yang dari 5 ini, ada juga yang 6 yang naturally occurring source whose discharge is created or exacerbated. Artinya yang secara natural memang si kontaminasi itu udah ada. Contohnya ini di dekat pantai biasanya airnya kan rada payau gitu ya. Nah, ini sebenarnya kita bisa bilang kontaminasi tapi natural, artinya memang di daerah dekat pesisir airnya pasti sedikit lebih, kandungan garamnya lebih tinggi dibanding yang sudah menjauh ke permukaan. Nah, kemudian kondisi bisa diperburuk ketika di sekitar pantai ini pengambilan air tanahnya tinggi. Artinya ketika pengambilan air tanahnya tinggi, headnya turun. Untuk mengimbanginya, ini ada air laut yang kemudian masuk ke dalam sistem air fresh tadi itu, sehingga menyebabkan intrusi air laut. Salah satu contohnya itu untuk yang natural, atau memang di beberapa tempat, misalnya daerah yang daerah sulfidasi, gitu, lereng yang terbuka, nah itu juga airnya pasti kualitasnya, air tanahnya akan berbeda dengan air tanah yang umumnya kita pakai. Nah itu memang dari sananya udah seperti itu. Nah itulah natural contamination, kita bisa sebutnya natural karena memang kondisinya seperti itu. Nah kemudian bagaimana sih sebuah massa atau substance itu bisa transport atau bergerak di dalam media berpori atau media yang saturated. Nah ini ada beberapa proses, yaitu difusi, adveksi, dan dispersi, maupun di mechanical maupun hidrodinamik. Nah difusi itu dia pergerakan mass transport berdasarkan perbedaan konsentrasi. Jadi mau ada aliran atau tidak, si difusi ini akan tetap berjalan. Artinya ketika kita misalkan ini air biasa gitu ya, ketika kita tetesin tinta atau tinta berwarna gitu ya, dia pasti akan menyebar. Si partikel-partikel tinta itu akan menyebar ke segala arah karena perbedaan konsentrasi tadi, konsentrasi si tinta sama si air ini ada beda konsentrasi. Nah dia akan bergerak secara difusi. Nah kemudian selain itu adveksi. Adveksi itu dia pergerakan massa yang mengikuti dengan arah alirannya. Kalau kita lihat di gambar ini, arah flow direction-nya itu ke samping sana, kan? Kemudian ini ada source-nya. Ketika si source-nya itu menyebar mengikuti arah dari flow-nya, nah itu kita sebut adveksi. Nah kemudian ketika si di dalam perjalanannya ini, pastikan di dalam media berpori itu, porinya itu bentuknya nggak mungkin seragam, pasti ada yang sempit, ada yang lebar bukannya, kemudian ada yang tersortir dengan baik, ada yang tidak tersortir dengan baik, artinya bisa menyebabkan alirannya lambat atau cepat karena perbedaan pornya atau pori-porinya. Kemudian ada yang alirannya itu mempunyai jalur yang lebih panjang, ada jalur yang pendek, itu karena sortingnya tadi, sama ada akibat adanya friksi atau gesekan antara fluida dengan medianya, media alirnya. Nah dia akan menyebabkan perbedaan aliran juga, ada yang slow, ada yang fast. Nah akibat ada ketiga faktor ini, di dalam sistem ini bisa terjadi mixing juga antara sumber kontaminan dengan daerah arah alirannya. Nah di situ disebut mechanical dispersion. Ada yang dia arahnya searah dengan aliran, misalnya arah penyebarannya. Kalau dispersion itu kita gampangnya penyebarannya searah dengan arah aliran, itu kita sebut longitudinal dispersion. Bisa juga dia yang tegak lurus, misalnya alirannya arahnya ke sana, kemudian dia mixingnya bisa menyebarnya ke tegak lurus dengan arah alirannya. Nah itu kita sebut transverse dispersion. Nah kemudian ketika ini kan kalau dalam satu sistem ini ada yang gerak kontaminannya itu searah, yang mengikuti arah aliran, difusi, sama dia menyebar, dispersi. Nah, gabungannya itu antara dispersi sama difusi itu hydrodynamic dispersion. Karena ini tidak kedua hal tersebut kan kadang tidak bisa dipisahkan gitu ya. Nah, itulah yang biasa kita sebut yang bisa istilahnya bloom tadi itu. Nah, itu gabungan antara mechanical dispersion sama diffusion. Jadi dia penyebarannya mengikuti arah aliran, kemudian karena ada perbedaan konsentrasi juga. Nah, kemudian kalau bicara modeling mode flow itu kita berawal dari persamaan Darcy yang dimana flux itu atau Darcy flux dari Darcy's law itu Q sama dengan K dikalikan dengan gradien hidrolik. K ini konduktivitas hidrolik. Untuk media yang isotropik ini dia hanya persamaan ini berdasarkan spasial aja. Nah, kemudian kalau misalnya dia ini steady state ya, artinya tidak berubah terhadap waktu. Nah, pada kenyataannya pergerakan aliran air tanah itu dia fungsinya bergantung terhadap waktu dan space juga, selain ruang, spatiotemporal artinya space dan time. Jadi dia hubungan dengan space fungsinya tergantung dengan areanya, kemudian juga bergantung terhadap perubahan waktu, berubah terhadap waktu. Ini sedikit aja. Jadi mode flow itu menyelesaikan merupakan solusi untuk memecahkan persamaan ini. Jadi intinya di satu blok ini kita masukkan parameternya. Parameter apa? Konduktivitas hidrolik, kemudian storage-nya berapa, kemudian head-nya berapa. Nah, kemudian mode flow itu menghitung melalui persamaan yang steady state maupun yang transient. Kira-kira seperti itu. Oke, untuk selanjutnya di agenda ketiga kita bahas modeling menggunakan mode flow. Nah, pertama kita harus kenali dulu role dan prosesnya. Ini saya ambil dari bukunya Bear and Cheng tentang modeling groundwater flow dan contamination menggunakan mode flow. Nah, ini modeling ini role-nya adalah kita intinya untuk mengambil keputusan dari permasalahan yang kita miliki mengenai aliran air tanah. Itu kita lihat dulu problemnya apa, kita manage problemnya seperti apa yang ada, terus kita tentukan tujuannya kita tujuan dari modeling ini untuk apa. Nah, kemudian dari setelah kita menetapkan tujuannya, kemudian kita pilih alternatifnya nih, mau pakai model yang seperti apa yang mau kita prediksi, kemudian kita menggunakan model untuk untuk mengestimasi atau memperkirakan respon sistem itu terhadap alternatif solusi yang sudah kita tetapkan. Kemudian kita evaluasi tujuannya dari fungsi dan batasan yang setiap model pasti ada batasannya kan. Nggak mungkin kita bisa memodelkan sesuatu sama seperti aslinya. Karena kalau sama seperti aslinya, parameternya akan sangat banyak dan si engine perhitungannya juga pasti akan kesulitan untuk mengevaluasi tujuan yang kita inginkan. Nah, makanya ada batasan. Nah, ketika sudah kita evaluasi, ini bisa dari sini kita bisa coba lagi, misalnya kita masih ada yang kurang, kita bisa propose lagi alternatif solusinya seperti apa, kemudian kita modelkan lagi. Setelah kita udah oke, kemudian kita pilih alternatif itu yang bisa kita implementasikan yang mana. Setelah itu kita implementasikan ke lapangan dengan adanya monitoring. Kemudian ya, dari monitoring itu hasil implementasinya seperti apa, apakah penerapan model yang kita sudah hitung di lapangan itu efektif atau masih ada yang kurang. Nah, kalau misalnya ada improvement, itu bisa kita kembali lagi ke proses awal. Nah, role-nya pemodelan tuh di situ. Kemudian kalau dari prosesnya, yang pasti kita butuh banyak informasi nih. Informasi yang dibutuhkan untuk memanage problem tadi. Kita nggak bisa memanage problem kalau kita nggak punya data gitu ya. Kalau misalnya hanya dari katanya, yaitu ya belum terbukti. Benar nggak masalah itu ada? Ternyata pas dicek di lapangan, mungkin masalahnya bukan itu. Nah, makanya kita harus punya data lapangan. Setelah kita punya data lapangan, kemudian kita buat model konseptualnya. Jadi misal dari data lapangan itu, misal kita punya geologinya, dia aluvium gitu ya. Kemudian ada sumber kontaminasi dari landfill. Kemudian ada di sekitarnya ada pemukiman yang memakai sumur bor atau sumur gali buat ngambil air tanah. Nah, itu adalah data-data yang kita kolek tuh. Data geologinya kita mapping, batuannya seperti apa, kemudian data air tanahnya kita ambil, ketinggian air tanahnya berapa, ketinggian air tanahnya, kualitasnya, kemudian kita cek potensi sumber kontaminan tadi, kondisinya seperti apa, apakah si landfill itu dibuat atau dibangun dengan baik, apakah ada licin atau rembesan kontaminan yang rembes masuk ke air tanah. Nah, itu yang kita ambil di lapangan datanya. Nah, setelah kita konsep, kira-kira berarti ada kemungkinan kontaminasi dari landfill tersebut ke sumber warga. Baru kita buat model matematisnya. Nah, model matematisnya ini bisa dimasukkan ke dalam workflow tadi, biar dia yang hitung, kita hanya memasukkan parameter-parameter dan variabel yang kita dapat di lapangan atau dari, kalau misalnya kurang, kita dari studi literatur. Nah, kemudian kita pilih solusinya, kita mau ngitung flow-nya aja, atau kita mau ngitung konsentrasinya juga, penurunan air tanahnya juga atau enggak, kemudian kesetimbangan air tanahnya seperti apa. Nah, ini di Moodle ada beberapa metode solusi atau kode yang tersedia. Nah, kemudian setelah model itu dibuat, kita bisa jadikan model tersebut sebagai predictive model untuk mensimulasikan kira-kira ketika si sumber kontaminan itu ada selama berapa tahun, penyebaran dari kontaminasinya itu seperti apa. Nah, tapi hal yang penting dalam pemodelan adalah kalibrasi dan validasi. Ini artinya ketika kita buat konseptual dan mathematical model ini, untuk sebelumnya jadi predictive model, kita harus kalibrasi. Jadi tujuannya, apakah data yang sudah kita ambil di lapangan, yang kita masukkan ke konseptual dan mathematical model ini, ketika dihitung dengan engine atau metode solusi dari Modflow ini, apakah dia valid atau terkalibrasi dengan baik. Nah, kalau misalnya terkalibrasi dengan baik, baru dia bisa menjadi istilahnya representatif untuk memprediksi kondisi kondisi ke depan seperti apa. Nah, setelah kita model itu terkalibrasi dan bisa menjadi predictive model, ini kita bisa melakukan analisis uncertainty atau sensitivity analysis. Jadi kita lihat si model ini dia sensitifnya parameternya terhadap apa, kemudian uncertainty-nya bergantung terhadap apa, bisa topografi, kemudian geologinya, apakah ada struktur. Nah itu nanti bisa di improve lagi modelnya agar lebih istilahnya itu tadi lebih representatif. Nah setelah itu baru kita dapat informasi, oh ternyata setelah diprediksi si model ini menghasilkan output bahwa penyebarannya ke arah mana selama berapa tahun. Nah itu bisa jadi informasi untuk memutuskan suatu kebijakan atau suatu langkah dalam walau profesional untuk kita maju atau enggak nih gitu. Nah ini tadi sedikit tentang Moodflow. Dia adalah bahasa pemrograman yang dibuat oleh USGS. Dia sebenarnya open source gitu ya. Jadi kita bisa download bahasa pemrogramannya, cuman tadi karena saya lebih familiarnya dengan yang sudah menggunakan software yang graphical user interface-nya ada, jadi kita tinggal masukin aja parameternya. Jadi lebih mudah, tidak perlu pemrograman yang lebih lanjut gitu ya. Jadi kita tinggal masukin aja parameter yang kita punya apa. Tapi kalau misalnya kalian para peserta Bapak Ibu ingin lebih mendalami, nah silakan aja buka di sini banyak cukup update Moodflow ini sampai sekarang udah Moodflow 6 terbaru. Cuman kita sekarang akan lebih ke Moodflow yang klasik, visual Moodflow klasik. Karena itu yang menurut saya lebih, bagi saya lebih familiar. Kalau misalnya ada yang lebih sering memakai aplikasi lain, mungkin nanti bisa kita saling sharing gitu ya. Nah ini untuk user interface-nya seperti ini. Jadi ini inputnya kita menetapkan grid-grid dari model yang kita ingin buat gitu ya, gridnya. Kemudian kita bisa masukkan propertinya, kemudian kita bisa juga masukkan boundary-nya, boundary kondisinya apa. Kemudian kalau misalnya ada sumur, kita mau masukkan sumur pantau atau sumur pemompaan atau injeksi, itu juga bisa kita masukkan di sini, tinggal kita pilih menunya. Ini nggak terlalu, kalau untuk beginner, kalau untuk memulai simple case bisa dengan ini. Cukup mudah, nggak terlalu sulit menurut saya. Oke, kemudian itu aja mungkin mengenai sampai Moodflow, sedikit mengenai kontaminasi, mengenai groundwater, siklus air, dan agenda terakhir kita langsung aja latihan kali ya. Sebelumnya kalau boleh nanya, udah ada yang download si aplikasinya? Halo, apakah terdengar suara saya?
Terdengar, Mas.
Gimana? Udah ada yang mendownload atau yang udah ada punya aplikasinya? Kalau udah, bisa kita apa namanya, coba bareng-bareng gitu ya. Kita pakai case yang simple aja. Kalau kita lihat exercise-nya, nah kita coba buat model pergerakan kontaminasi dari landfill gitu ya. Ini yang biru itu sumber kontaminasinya. Kemudian di sini ada beberapa sumber pemantauan konsentrasi. Kemudian di sini ada pumping wells yang merepresentasikan di sini ada daerah pemukiman gitu. Di sini juga. Nah, kemudian si head air tanahnya kita buat arahnya itu dari kursor saya ini dari kiri ke kanan lah cenderung. Gimana nih, kok nggak ada yang jawab? Apa udah di-download atau belum? Bapak Ibu? Oke, sekalian install. Bagi yang sedang install, kita buka tanya jawab dulu aja kali ya. Barangkali ada yang ingin bertanya. Silahkan. Langsung nanya aja kali ya. MC-nya gimana, Pak? Kalau tanya jawab? Diskusi? Langsung nanya
Iya,
aja.
boleh Pak.
Oke, silakan.
Bisa langsung tanya aja. Ini dari kolom chat sih, beberapa lagi sedang install Pak.
Iya.
Oke, jika ada pertanyaan boleh langsung ditanyakan.
Boleh, Pak Aris silakan. Bertanya, silakan aja langsung.
Halo, mohon maaf,
Ya.
MC. Ya, terima kasih. Saya tidak apa-apa ya, Pak, tidak menyalakan kamera.
Iya, nggak apa-apa, Pak. Yang penting suaranya kedengeran.
Tapi suara saya jelas ya, Pak ya?
Jelas.
Oke, terima kasih atas waktunya dan juga presentasinya. Saya Aris dari Ilmu Kelautan Universitas Trunojoyo, Pak, dan teman-teman semua. Menarik sekali paparan yang disampaikan. Terus terang saya belum pernah menggunakan software ini karena memang ini berkaitan sekali sama software hidrologi. Tapi pengalaman saya selama ini saya biasa memodelkan tapi untuk sedimen transport, Pak. Nah, pertanyaan saya adalah apakah software ini juga bisa atau representatif untuk memodelkan atau untuk membuat estimasi terkait transport sedimen yang ada di daerah delta atau jika memungkinkan di daerah sepanjang pantai. Itu saja sih, Pak, pertanyaan saya. Terima kasih.
Kalau sebelumnya pakai softwarenya apa, Pak, modelinnya?
Saya bukan, saya menggunakan SMS, Pak.
Oh, SMS.
terus modeling dan juga Mac 21. Cuman belakangan karena dua software ini juga lisensi, saya akhirnya berpindah menggunakan saya ngoding sendiri menggunakan bahasa program MATLAB. Jadi ya memang ada banyak kelemahan, tapi saya lebih leluasa untuk improve persamaan karena develop sendiri untuk modelnya.
Saya izin menjawab Pak ya. Kalau Flow sendiri sebenarnya kan engine-nya banyak tuh Pak. Kalau dilihat di USGS-nya, setahu saya ada engine yang untuk surface water. Nah, cuman saya belum tahu apakah bisa sampai analisis sedimen tadi ya, perpindahan sedimen transport tadi, apakah bisa sampai situ juga. Cuman untuk pemodelan air permukaan di Flow seharusnya ada juga Pak Aris.
Oh gitu ya Pak ya.
Ya.
Mohon maaf, apakah bisa dikorelasikan ya Pak dengan jenis tanah yang juga bisa didetek dalam model ini? Karena saya berpikir dari beberapa konsep persamaan yang saya gunakan untuk mengembangkan model, saya juga mempertimbangkan jenis tanah. Apakah bisa diekstraksi juga atau mungkin dicarikan semacam kesetaraan, artinya mungkin karena saya tidak yakin bisa mendapatkan persamaan ataupun model matematis yang digunakan oleh software ini, sehingga saya tidak mendapatkan point of view yang memadai supaya bisa saya combine juga dengan model yang sedang saya develop menggunakan MATLAB.
Butuhnya parameternya apa tuh Pak?
Kalau yang saya ekstrak yang pertama adalah saya butuh parameter jenis sedimennya Pak.
Jenis sedimen itu dari segi porositasnya, butirannya, atau apanya?
Saya masih fokus dengan ukuran butir Pak, belum sampai ke porositas.
Oh, ukuran butirnya ya?
Iya.
Kalau di Flow yang ini sih sepertinya saya cek dulu Pak. Saya juga sebenarnya belum pernah untuk memodelkan itu, cuman kayaknya sih belum sampai si untuk yang Flow ini dia mainnya tuh di porositas, jadi bentuk butirnya itu nggak menjadi inputan atau output dari modelnya ini.
Oh begitu ya Pak, maaf saya memotong lagi. Apakah kata-kata mood flow dari nama model ini berkorelasi atau berkaitan dengan jenis tanahnya yang dimodelkan untuk alirannya ya Pak?
Gimana Pak?
Apakah nama software ini kan namanya mood flow ya Pak?
Iya, iya.
Apakah mood yang di sini kalau dilihat dari tulisannya kan sebenarnya bukan mood yang jenis tanah ya, tapi saya tidak tahu apakah nama model ini yang mood flow ini ada kaitannya dengan substansi tanah yang dimodelkan alirannya Pak.
Kalau dari persamaan tadi Pak, ini kan dia modeling aliran air tanahnya ya, alirannya, lebih ke alirannya dia.
Oh, berarti tapi di situ berarti asumsinya yang bergerak hanya airnya ya Pak ya, tidak termasuk substansi yang ada dalam airnya ya Pak?
Iya, lebih ke air sama konsentrasinya paling Pak. Kalau yang untuk engine yang kontaminan ini dia konsentrasinya yang bergeraknya.
Konsentrasi ini apakah berkaitan sama kepekatan Pak?
Konsentrasinya itu sebentar. Nah, reaksinya Bisa sih kalau misalnya ada reaksi yang kinetiknya gitu ya, atau ada penyerapannya juga. Cuman itu juga saya belum jujur aja belum sampai situ sih, karena jarang memodelkan yang sampai apakah si substansi dari butiran-butirannya itu bergerak juga terus ngumpul di mana. Nah, ini cuman berbicara sebatas apa namanya, dari perbedaan konsentrasi tadi itu si penyebaran kontaminannya seperti apa di dalam tanahnya gitu ya. Nah, untuk hubungannya nanti ke air permukaan sepertinya harusnya sih ada modelnya juga, Pak. Nah, cuman itu saya belum apa namanya, belum pernah ngeran sampai segitu.
Oke Pak. Saya dapat poin sekarang. Terima kasih atas penjelasannya.
Mungkin kalau kita
mungkin
mau
kalau
diskusi lebih lanjut di luar forum ini aja kali Pak ya.
Iya. Nanti minta tolong saya nanti tak email aja ke email panitia untuk mendapatkan kontak sama email jenengan ya.
Ya siap Pak Aris.
Terima kasih Pak.
Ya, Pak Aris dosen apa tadi? Dosen Pak ya?
Ya, saya dosen di program studi ilmu kelautan Pak.
Oke. Baik. Dari Universitas
Trunojoyo, Madura.
Oh, di Madura. Ya. Baik. Siap Pak.
Terima kasih ya Pak atas waktu
Sama-sama
dan
Pak Aris.
penjelasannya.
Ya.
Terima kasih moderator.
Terima kasih Pak. Ini ada pertanyaan lagi Pak dari Sadewa Purba Sejati. Bertanya, apakah prinsip kerja Modflow yang digunakan dalam sharing session ini sama dengan software Visual Modflow Flex versi 6.1? Terima kasih.
Sama aja, cuman Visual Modflow Flex itu dia lebih terbaru versinya. Artinya Flex ini dia gridnya bisa fleksibel. Artinya kalau yang klasik dia kan gridnya persegi ya, kotak gitu. Nah kalau Flex itu gridnya bisa dibuat fleksibel, jadi seperti finite element gitu. Nah kalau yang klasik dia karena finite difference jadi bentuknya kotak-kotak gitu. Cuman bisa di-combine juga, Modflow Flex ini bisa menggunakan grid yang kotak atau grid yang triangulasi. Itu mungkin ya, Sadewa.
Baik, terima kasih Pak atas penjelasannya. Ada yang ingin bertanya lagi mungkin? Ada pertanyaan lagi Pak dari Putra Bagus Panji bertanya, untuk kontaminan yang dimodelkan di sini dapat berupa apa saja? Terima kasih.
Bisa apa aja sebenarnya, tergantung nanti data yang dipunya apa aja kan. Ini kan cuma bicara konsentrasinya aja, konsentrasinya berapa ppm atau berapa miligram per liter, nah itu yang kita input. Nah masalah jenis kontaminasinya tergantung, misalnya sumbernya apa, itu kan beda-beda. Nah kita bicaranya konsentrasinya aja, tergantung case-nya. Jadi bicaranya masih konsentrasinya aja, perbedaan konsentrasi tadi.
Baik, terima kasih Pak Fadil. Apakah ada pertanyaan lagi? Atau Putra Bagus Panji, apakah sudah puas dengan jawabannya?
Udah kita mulai aja kali ya.
Ini mungkin ada satu pertanyaan lagi Pak
Boleh, boleh.
Dari Fasri, apakah Matflow mungkin maksudnya ya, bisa digunakan untuk melihat pergerakan tinggi groundwater level, rainfall induced? Seperti itu, Pak.
Oke, kalau secara ini ketinggian groundwaternya karena rainfall gitu ya, infiltrasi gitu mungkin, atau gimana? Siapa tadi yang nanya?
Iya betul, Pak.
Ya, ya. Ya, kalau di sini di Modflow kan ada input dia recharge. Nah, recharge-nya itu dia lebih ke net recharge-nya, artinya bukan recharge dari full dari hujan, tapi recharge yang sudah terinfiltrasi atau yang sudah masuk ke dalam zona jenuhnya. Seperti itu. Tapi bisa juga kalau saya nggak salah kita rubah atau pakai software yang lain seperti ada itu yang untuk memodelkan apa namanya di zona unsaturated gitu ya. Saya lupa tuh nama softwarenya apa. Ada yang 1D, 2D, 3D. Nah, itu bisa untuk lebih detailnya. Cuman kalau untuk Modflow mostly atau umumnya si recharge-nya itu adalah sudah menjadi net recharge, artinya nggak semua hujan yang turun itu kita masukkan, tapi hanya si recharge itu yang dibaca adalah nah ini nih, hidrus ya, hidrus 1D, 2D, 3D untuk yang unsaturated. Terima kasih Pak Muhammad Abdul Razak. Itu kira-kira. Terus ini ada fracture aquifer. Bisa iya, tergantung. Kalau misalnya kita mau, ini bisa kita akalin dengan untuk fracture, tetap intinya kita harus membuat model itu sesimpel mungkin dan tetap merepresentasikan apa yang mau kita hitung gitu ya. Kalau misalnya udah terlalu, kalau zona aquifer kan dia pas zona fracture artinya di beberapa area titiknya itu nilai konduktivitasnya mungkin kita tinggikan, artinya untuk menandakan daerah tersebut fracture, simpelnya seperti itu. Cuman kalau memodelkan lapisannya fracture itu rada sulit di Modflow karena dia gridnya tadi terbatas gitu ya. Kalau semakin detail dan rapat gridnya, otomatis perhitungannya akan semakin sulit. Artinya untuk mencapai hasil perhitungannya itu akan susah kita mencapai konvergensinya, dan nanti errornya juga pasti akan tinggi gitu. Dari Fania tadi ya.
Iya baik, terima kasih Pak Fadil. Mungkin untuk saat ini cukup segitu dulu pertanyaannya. Bisa dilanjut mungkin Pak dengan pemodelannya.
Ya, oke. Baik, kita lanjut ya. Tapi saya lagi buka aplikasinya. Oh, ini kalau detail hidrogeologi kayaknya yang saya tahu belum ada deh, masih secara regional aja nih kalau peta hidrogeologi, cekungan air tanah gitu ya, hidrogeologinya. Dari Pak Hengki Purwonegoro. Baru peta cekungan air tanah regional aja sepertinya Pak, yang saya pernah lihat gitu ya untuk mapping. Oke. Ya, sudah terlihat ini tampilan ketika baru membukanya seperti ini. Nah, untuk karena kita awal, kita new saja. Kemudian kita terserah namanya. Saya coba foldernya juga silahkan taruh di mana aja di drive masing-masing PC-nya. Oke, kita coba trial atau tes model. Nah, di sini apa namanya kita tentukan parameter apa namanya modelnya. Kita mau pakai engine yang mana? Kalau untuk modeling flow kita pakai mode flow ini nih. Biasanya kalau nggak 2000, yang terbaru itu 2005. Kalau di visual mode flow flex atau aplikasi lain mungkin sudah bisa gunakan mode flow 6 gitu ya untuk flow engine-nya. Nah, kemudian kita tentukan unit-unitnya, kita mau pakai satuannya apa, panjangnya meter, ini tergantung preferensinya apa, time-nya mau hari, waktu, atau tahun, detik, menit, jam, hari, atau tahun, tergantung kebutuhan. Biasanya saya pakai hari, kemudian ini konduktivitasnya, umumnya saya pakai meter per detik, pumping rate, bisa meter kubik per day, atau liter per detik, tergantung preferensi Bapak Ibu. Ini recharge-nya tadi milimeter per year, normal ya. Kemudian konsentrasinya miligram per liter atau mikrogram per liter. Kita pakai miligram per liter aja. Nah, ini sisanya kita pakai yang standar aja, itu saturated, yang saturated, kemudian ini constant density, ini kalau misalnya saturatednya variably, ada perbedaan density-nya, atau kita mau uap. Tapi kalau untuk flow, kita di sini aja dulu dengan model yang 2000 flow 2005. Kemudian untuk kontaminannya, ini kita yes, ini engine-nya seperti ini. kemudian kita next. Nah, ini kemudian kita tentukan ini parameter default dari bawahannya. Ini bisa kita biarkan saja dulu, nanti bisa kita ganti sendiri. Nah, ini kalau steady state dia tidak berubah terhadap waktu. Kemudian kalau transient, ini berubah terhadap waktu. Ini kita pilih yang transient aja. Karena kita mau coba simulasikan selama waktu tertentu gitu ya, perubahannya seperti apa. Biasanya kalau untuk model yang awal itu kita harus buat yang steady state dulu. Jadi di satu waktu tertentu kita punya datanya, kondisi headnya seperti apa di satu waktu, kita buat steady state flow-nya dulu. Nanti kalau sudah terkalibrasi dengan baik, baru kita gunakan model tersebut jadi transient model. Artinya ketika udah waktunya berubah, nah gimana respon dari si model tersebut. Sehingga kita bisa membuat prediksi gitu ya, predictive model. Nah, ini untuk parameter penyebarannya. Ini juga bisa kita tinggalkan dulu default gitu ya. Nanti kalau misalnya mau ganti, bisa diganti tergantung kondisinya. Nanti dicek dulu areanya itu dispersivitasnya seperti apa penyebarannya. Kemudian koefisien dispersity-nya seperti apa, diffusi. Nah, itu nanti tergantung dari data yang ada. Nah, sekarang kita ikutin aja default-nya seperti ini. Nah, ini tadi si kontaminannya. Ini terserah kita namainnya mau apa. Tergantung jenis kontaminannya. Kalau kita mau masukin konsentrasi awalnya bisa di sini, kalau enggak bisa nanti kita input sendiri. Oke, setelah itu kita tentukan batasan model kita. Kalau misalnya kita punya koordinat tertentu, bisa kita masukkan nih koordinat X minimumnya berapa, Y minimumnya berapa. Terus kita mau buat berapa kolom, misalnya kita nggak usah terlalu besar gitu ya. X maksimumnya 500. Ya, terus jadi modelnya itu batasnya 500 kali 500 dengan jumlah kolomnya ada 50. Artinya setiap blok itu ukurannya 10 meter. Ini juga sama. 50 kali 50. 50 ada 50 kolom dan 50 baris. Masing-masing dimensinya itu 10 kali 10. Nah, kemudian kita mau berapa layer? Ini kita buat aja 3 layer gitu ya. Jadi ada aquifer yang confine, aquifer bebas, kemudian ada lapisan permeabelnya, kemudian di bawahnya ada aquifer dalamnya. Ini Z-nya kita bikin minimumnya misal minus 200, kemudian ini 50. Nah, ini juga nanti bisa kita adjust lagi ketika sudah dibuat modelnya. Dan create. Kita masuk ke sini nih, ke bagian input sekarang. Nah, ini jadi ini box ini posisi kita sekarang ada di layer pertama. Kalau misalnya kita mau lihat layer keduanya, tinggal go to bisa layer 2, kita ada di layer 2. Atau bisa ini, previous, next, previous. Nah ini untuk pindah-pindah layer kalau kita mau masukkan parameter tadi. Nah kalau misalnya kita mau lihat tampilan sectionnya, kalau kita mau lihat secara vertikal, kita view column, kita lihat mau di mana, misalnya di sini. Ini posisi layernya. Jadi kalau 3 layer kemudian kita tentukan berapa Z maksimum dan minimumnya. Nah ini dibagi rata. Nah kalau misalnya kita mau rubah itu, kita kembalikan dulu ke view layer tadi. Kita pilih layer 1 misalnya. Nah kita bisa assign elevation. Kita mau single titik-titik tertentu, kita elevasinya mau kita assign, atau kita mau buat garis, atau polygon, atau window atau kotak, atau kita bisa juga import. Nah, kalau import kita bisa pilih mau ground surface, bottom layer 1, layer 2, layer 3. Nah ini kita bisa pilih tergantung apa namanya, data yang kita punya. Kita bisa import datanya itu dalam poin, apa namanya, XYZ file, kemudian dem juga bisa, grid bisa, save file, SHP juga bisa. Nah ini tergantung ketersediaan data yang ada. Nanti dia juga bisa interpolate daerah sekitarnya kalau nggak ada data. Kemudian kita bisa juga menentukan elevasinya atau ketebalannya atau slope dari 3 titik gitu ya. Atau elevasi, kedalaman juga bisa. Kita tentukan kedalamannya berapa. Atau kalau kita assign misalnya elevasi ini, kita sepanjang ini kita coba buat datar aja gitu ya. Jadi kita klik dari ujung ke ujung. Kita bisa tentukan bottom elevation-nya yang kita tentuin atau top-nya. Kalau misalnya bottom-nya, kita coba karena tadi top-nya 50, kita coba aquifer atasnya 20 meter aja jadi 30 gitu ya. Elevasinya. Sekarang kita cek benar nggak. Ini kan jadi kita zoom in. Nah ini kan jadi lapisan, ini topnya, lapisan layer 1 top, kemudian ini bottomnya layer 1 di 30 tadi karena kita assign di 30. Kemudian kita coba yang layer 2 sekarang. Ini kita ada di layer 2. Kita masukkan lagi, assign lagi elevation-nya. Klik dari ujung ke ujungnya. Jadi kita buat 3 lapisan datar aja gitu ya. Ini topnya elevasinya 30, bottomnya kita coba si kedalamannya 15 meter aja. Atau 10 meter deh. Ini 30, ini 20. Jadi kita view lagi ininya. Nah, 50, 30. Kemudian ini kita kembali lagi sekarang ke layer 3. Sekarang kita assign lagi. Ini topnya di elevasi 20, bottomnya biar nggak terlalu dalam, kita minus 100 aja. Jadi aquifer, nah inilah, ini aquifer ini terlalu dalam, di edit lagi, minus 50 deh. Oke. Nah ini 30 meter, ini 10 meter, ini 70 meter gitu ya, aquifer dalamnya. Jadi ini aquifer bebas, kemudian ini confining layer atau lapisan permeabelnya, non aquifer, kemudian ini aquifer dalamnya. Nah ini gridnya seperti ini. Atau kalau misalnya kalian mau elevasinya beda juga nggak masalah, silakan aja. Intinya dibuat 3 lapis gitu ya, lapisan aquifer di layer pertama, yang kedua lapisan non aquifer atau lapisan confining layernya, yang ketiga lapisan aquifer lagi, aquifer dalamnya. Kemudian setelah itu ini kita back main menu dulu, save. Ini main menunya, kita masuk ke input lagi. Sekarang kita masukkan propertinya nih, conductivity-nya. Nah untuk ngecek ini nilainya berapa, yang putih itu, kita lihat aja database. Nah ini nilai konduktivitas hidroliknya 0,0001, 1 kali 10 pangkat minus 4. Nah ini cukup sangat baik buat jadi aquifer nih. Tapi biasanya, nah ini nanti si konduktivitas hidrolik ini juga bisa diimport. Kalau misalnya kita punya data gitu ya, datanya bisa save file, kemudian grid atau XYZ, tapi harus koordinat sistemnya harus sama nih, referensinya. Kalau misalnya batasnya segini, berarti datanya juga harus mengikuti. Kalau misalnya nggak seluruhnya, nanti dia minta interpolasi. Jadi bisa juga interpolasi di sini. Itu bisa import tadi, atau bisa juga kita assign pakai polygon atau pakai window atau single per block. Sekarang kita single aja, window. Nah, sepanjang ini ibaratnya seragam. Kita buat yang baru. Misalnya untuk aquifer itu ya sekitar segini udah cukup baik lah. Nggak terlalu kecil, nggak terlalu besar. Ya, ini artinya 5 kali 10 pangkat minus 6 ya. 6. Nah, untuk Z-nya biasanya ordernya turun 1, artinya lebih kecil 1 order. 5 kali 10 pangkat minus 7. Biasanya nentuinnya gitu. Karena supaya dia si flow-nya itu lebih lateral gitu ya. Atau kalau punya data ininya tergantung data, kalau punya data yang KZ-nya KX, KY, KZ, nah itu lebih bagus diimport tadi. Nah ini untuk yang aquifer. Kemudian yang kalau yang aquifer dalamnya mau sama, ini kita tinggal copy aja. Copy layernya, dan kita klik zone-nya. Terus kita mau copy ke layer berapa? Bisa ke layer 3. Jadi layer 3 kita dapat. Nah, kemudian selanjutnya untuk yang confining layernya pasti konduktivitas hidroliknya harus lebih kecil. Dan new lagi, ini kita coba aja 1 kali 10 pangkat minus 8 lah, atau ya segitu, 1 kali 10 pangkat minus 8 plus 10 pangkat minus 9. Nah, ini untuk konduktivitasnya. Kemudian storage-nya. Storage-nya kita lihat database-nya. Nah, kalau segini mah cukup baiklah buat aquifer gitu ya. Sekarang berarti yang kita bedain buat yang non aquifernya aja. Layer 2. Nah, ini kita new. Ini specific storage-nya kita samain aja. Minus 5 tadi. Kemudian yield-nya karena dia non aquifer artinya yield-nya akan kecil gitu ya. Saja 0,1. Efektif porositasnya juga kecil, 5. Tapi porositasnya pasti tinggi. Kalau lempung gitu, porositasnya dia bisa, total porositas kan perbandingan rongga sama apa namanya, volumenya. Artinya kalau semakin halus, total porositasnya akan semakin tinggi, 0,5. Tapi kalau lempung dia susah mengalirkan kan karena efektif porositasnya kecil. Oke, udah. Sekarang initial head-nya. Ya, initial head-nya karena ini datar, kita coba aja, kita buat asumsikan kita buat gimana caranya si head itu, aliran air tanah itu mengalir ke arah dari kiri ke kanan. Berarti kan head itu harus bergerak dari head yang tinggi ke rendah ya. Berarti artinya head sini itu harus tinggi dan head yang di sana harus lebih rendah. Kita bisa gambar window dulu. Head yang paling rendahnya berapa? Misalnya karena ketinggiannya 50, head paling rendahnya 45 deh. Ya, kemudian kita assign lagi sebagian sampai sini. Ini baru lagi, ini lebih tinggi lagi, 46. Dan assign lagi. Ini naik lagi. tinggal sign lagi aja. Kemudian kita sign lagi. Empat, 8. Sign lagi. Sembilan. Oke, pasti karena ini ada ya. Ini pasti kemungkinan ini kita coba si aliran itu bergerak dari kiri ke kanan. Ini untuk layer 1. Kalau untuk layer 2, layer 3-nya kita samain aja. Jadi bisa kita copy di layernya. Di layer 1 copy ke semuanya. Sudah kita copy, ini jadi sama untuk layer 1, 2, 3. Nah, ini kita dapat head-nya. Nah, kemudian untuk konsentrasinya kita lihat konsentrasi inisialnya, database-nya 0. Asumsinya kita awalnya nggak ada kontaminasi gitu ya, nggak ada sumbernya, cuman kita masukkan di boundary-nya nih. Di boundary-nya itu kita anggap ada di layer pertama, di bagian bisa dibilang hulunya gitu ya, bagian upstream-nya, ini ada landfill tadi. Gambar sembarang aja. Nah, misalnya dia selama 10 tahun gitu ya, dengan konsentrasi yang konstannya misalkan 500 mg per liter. Ini senyawanya bisa apa aja ya, tergantung. Ya intinya konsentrasinya aja. Dengan senyawa tertentu gitu ya. Selama 10 tahun ada sumber kontaminasi dari sini sebanyak 500 mg per liter. Konstan gitu di sini. Kemudian dalam model kita butuh kondisi batas buat flow-nya. Bisa constant head, atau misalnya ada sungai, atau ada danau, atau ada recharge tadi. Misalnya kita ada di bagian hulu sini ada danau gitu ya. Ini ada danau. Tampilan danaunya. Danau. Dia sama juga selama 10 tahun. Waktu simulasi kita buat 10 tahun. Anggapannya setahun itu 360 hari, biar mudah ngitungnya. Jadi kalau 10 tahun 3.600 hari. Kemudian head-nya sama seperti tinggiannya 50 meter. Kemudian stop time head-nya juga 50 meter. Ini kita anggap udah, boundary-nya kita pakai satu aja, nggak usah banyak-banyak. Oke, habis itu kita masukkan sumur pantaunya. Nah ini kita lihat dulu posisi-posisinya di overlay ini. Kalau kita mau lihat boundary condition, tadi kita masukin itu adalah constant head dan constant concentration. Di posisi constant head sama constant concentration ya. Kemudian kita masukkan sumur pantau atau sumur pantau konsentrasinya di beberapa titik gitu ya. Contoh di sininya. Kita tulis observasi 1. Nah, ini tampilan lapisannya. Kita lihat screen-nya di mana. Ini kita 00 dulu aja karena kita nggak ada data. Kecuali kalau ada data. Nah, ini bisa ditulis nih konsentrasinya di lapisan aquifer ini berapa di waktu tertentu. Kemudian kalau misalnya mau di aquifer yang non aquifer ini juga bisa. Dan di masing-masing aquifer juga bisa. Oke. Nah, kalau mau ditambah lagi, ini semakin jauh. Observasi 2. Ini kita set lagi. Lalu nah, kita cek lagi semakin jauh. Observasi 3 sama di sisi sebelah sininya juga kita mau cek bisa. Kita masukkan aja titik observasi 4. Screen-nya yang A aquifer 1, B aquifer 2, C aquifer 3. Cukup. Kemudian kalau kita memasukkan sumur pompa gitu ya, bisa juga. Misalnya di sini ada pemukiman gitu sekitar sini. Kita add well, pump 1. Ini mau berapa lama? Kalau kita samakan berarti 3.600 hari selama 10 tahun juga. Rate-nya berapa? Debitnya. Misal apa namanya? Satu desa gitu ya. Satu desa itu ada 50 kepala keluarga. Setiap keluarga itu ada 5 anggota masing-masingnya. Seorang kan rata 100 sampai 150 liter 150 liter per hari ya kebutuhan air. Kita anggap aja 100 lah dikali 5, satu keluarga 500 setengah meter kubik. Berarti kalau ada 50 keluarga berarti setengah berarti 25 meter kubik per hari untuk 50 keluarga gitu ya. Di minus jangan lupa. Kalau rate minus berarti dia narik. Kalau dia rate-nya positif berarti dia injeksi. Tahun ini dikali 2 deh, ada 100 deh. Jadi 50 meter kubik per hari. Nah ini kita coba satu dulu. Udah, kalau mau ini parameternya udah cukup, kita propertinya udah masukin, kemudian kondisi batasnya juga udah kita masukin beberapa. Minimal satu kita harus punya kondisi batas, baik itu flow-nya atau konsentrasinya, supaya model ini bisa di-run. Kemudian kita run. Nah ini kita lihat dulu time step-nya. Jadi selama 10 tahun ini dikali 1, jadi ada 10 time step. Jadi outputnya nanti datanya itu per tahun. Jadi tahun pertama, kedua, ketiga, keempat, kelima, 6 sampai ke 10 gitu ya. 10 step. Nah ininya harus kita centang. Kita centang aja semua. Ini data outputnya nanti yang di apa namanya, yang dihitung, yang ditampilkan. Nah kemudian ini engine untuk konsentrasinya. Nah ini untuk outputnya kita specified time-nya aja. Di per tahun berarti 360. Kemudian tahun kedua 720 sampai 360, 1080. Kemudian 1440, 1800, 160, 25, 20, 880, 3240, ini 400. Nah ini setiap tahun juga outputnya. Kita oke. Dan kita run. Udah finish successfully, close. Kita lihat outputnya. Nah ini hasilnya. Bisa kita lihat mau head-nya, mau konsentrasinya, atau drawdown-nya. Lihat head-nya dulu, perubahan head-nya di layer 1. Perubahannya seperti ini. Kita lihat ini ada, karena ada pumping, ada istilahnya ya, cone of depression. Jadi karena ada pumping, air tanahnya juga ada penurunan di sini, di titik pompanya. Kemudian kalau kita mau lihat konsentrasinya selama 10 tahun gitu ya, gerakannya. Nah, kita lihat karena sebenarnya alirannya kan ke sana ya, tapi karena ada pemompaan di sini, si plumnya ini atau penyebarannya dia terambil atau agak condong ke sini karena di sini ada penurunan head nih, artinya ada penurunan head, artinya si ini juga ikut bergerak ke arah penurunan head tersebut. Nah, ini kurang lebih seperti itu. Untuk simple case gitu ya. Jadi, nah untuk lebih ininya sih nanti kan tergantung data yang dipunya apa. Paling nggak tahu nih untuk modeling itu butuhnya apa aja. Tadi data konsentrasinya, kemudian observasinya seperti apa nih, sumur ada, harus ada titik pantaunya supaya bisa mengkalibrate nanti atau buat tahu kondisi selanjutnya seperti apa ke depannya supaya model tersebut bisa selalu terupdate gitu ya. Nah, untuk outputnya kita bisa lihat headnya, drawdownnya atau konsentrasinya secara time series. Karena saya nggak ada observation flow-nya, jadi nggak muncul. Kita lihat konsentrasinya. Kita lihat yang di layer 1. Nah, ini nih di observation 1, layer 1, observation 2, layer 2. Ini grafik konsentrasinya. Kalau kita lihat di layer 2 dan layer 3, bisa. Atau semuanya juga bisa. Ini datanya bisa kita ekspor nanti. Bisa kita ekspor semua. Tergantung kita mau sumur yang mana. Bisa kita save the file. Nah, bisa teks. Ini nanti kalau misalnya mau ditampilkan di dengan grafik yang lebih baik gitu ya, bisa per sumur atau semuanya. Nah ini nanti kalau apa namanya kalibrasinya, kalau kalian punya data observasi yang di satu waktu tertentu, nah nanti grafik ini nih yang harus kalian perhatikan. Jadi nanti residualnya harus apa namanya standar errornya harus kecil gitu ya. Terus koefisien korelasinya juga harus bagus. Karena ini nggak ada data kan, jadi kita belum membahas itu. Jadi hanya simple case aja, buat dengan perkiraan model yang udah kita ketahui kira-kira ini arahnya kemana. Nah, jadilah modelnya seperti ini. Yang penting sedikit paham user interface dari workflow itu kira-kira seperti ini. Oke, mungkin seperti itu aja. Saya mau nanya sebelum itu, yang survei tadi udah isi semua belum ya, Bapak Ibu? Karena selain survei yang tadi, saya juga ada survei post workshopnya. Jadi nanti saya share lagi nanti apa namanya survei atau input setelah seminar ini, setelah workshop ini seperti apa. Nah sebelum itu ada pertanyaan nggak? Ada yang kesulitan nggak kira-kira untuk user interface dari si Modflow klasik ini, visual Modflow ini? mangga kalau ada pertanyaan atau komentar Bapak Ibu.
Silahkan jika ada pertanyaan bisa langsung ditulis di kolom chat atau bisa langsung dinyalakan mikrofonnya. Ada pertanyaan Pak dari Mohrifan Tris apa? Dari Muhammad Rifdan Trisnadiansyah, di mana proses kalibrasi model sehingga kita dapat tahu bahwa hasil model itu mendekati kenyataannya.
Kita lihatnya tadi di koefisien korelasinya. Bisa dilihat dari situ. Kalau misalnya itu kan nilainya 0 sampai 1 ya biasanya. Kalau semakin mendekati 1 artinya kalau yang grafik tadi itu belum ada sebenarnya karena kan kita datanya ini data dummy dan nggak ada data kalibrasinya. Tapi kalau misalnya untuk nampilinnya sebentar. Ya. Intinya di tadi yang grafik tadi kita pilih kalibrasinya. Ini ada bermasalah screen saya, jadi nggak kelihatan. Nah itu nanti ada kelihatan di situ parameter statistiknya seperti apa. Nah yang salah satu jadi kuncinya yaitu tadi koefisien korelasinya.
Oke, baik. Terima kasih Pak. Ini ada pertanyaan lagi dari Yosi Andika. Bagaimana cara membuat aquifer serta menentukan kapasitas debit yang dihasilkan oleh aquifer tersebut? Terima kasih.
Cara membuat aquifer, kalau ini harus parameter aquifernya dari pumping test paling ya, kalau mau tahu kapasitas debit. Jadi ini data lapangan yang harus diambil ketika setelah ada sumur itu, ketika kita ngebor biasanya, kalau mau tahu kapasitas debit dari sumur itu ya kita pumping test. Jadi biar tahu debit optimumnya dari si sumur itu berapa, itu kita harus pumping test. Kayaknya untuk kalau literatur itu susah. Cuman kebanyakan orang itu ya kebanyakan user gitu ya. Dengan geolistrik aja udah pengen tahu debitnya berapa. Padahal untuk tahu debit aquifer tersebut ya kita harus uji. Ujinya ya salah satunya dengan pumping test. Gitu.
Iya, bagaimana? Apakah sudah terjawab pertanyaannya? Atau ada pertanyaan tambahan lagi? Jika tidak, lanjut ke pertanyaan selanjutnya dari Fania. Apakah modeling menggunakan node flow dapat menggunakan data KX, KY, dan KZ dalam satu layer?
Maksudnya kalau ya bisa. Jadi KX, KY, KZ dalam satu layer itu bisa sama dalam satu layer, bisa beda-beda juga. Dan nilainya juga tergantung. Kalau misalnya kita punya datanya, KX, KY, KZ-nya, hasil pengukuran gitu ya, itu bisa dimasukin. Bisa sama dalam satu layer, bisa berbeda dalam satu layer, tergantung data yang kita punya seperti apa.
Baik, terima kasih Pak Fadil. Ini ada pertanyaan lagi dari Agung Dwi Purnomo. Bertanya kapan kita perlu menggunakan general head, GHB, serta CHD, constant head, untuk menentukan boundary model. Saya sedang meng-create modeling groundwater level menggunakan free watt. Terima kasih.
Setahu saya kalau general head itu, misalnya kita di area model kita nggak ada, di lapangan itu nggak ada lokasi atau area yang bisa dijadikan general constant boundary gitu ya. Nah itu bisa diambil dari misalnya di luar area model kita yang kita nggak ada datanya, tapi ternyata ada kondisi batas di situ, misalnya ada danau atau ada apa yang jaraknya jauh di luar dari area model kita. Nah itu bisa dipakai general head. Nah, kalau constant head itu ya kalau misalnya di area model kita ada kondisi batas seperti danau tadi atau apa namanya ya danau lah kira-kira. Nah itu kita masukkannya constant head biasanya. Itu kira-kira Pak Agung Wipurnomo.
Iya, bagaimana Pak Agung Dwi Purnomo? Apakah sudah cukup? Oke, sudah cukup. Terima kasih Pak Fadil. Sebelum sesinya disudahi, apakah dari Pak Fadil ada kesan-pesan untuk acara ini atau mungkin ada pesan untuk para peserta dalam yang ingin menggunakan software ini nantinya?
Baik, terima kasih. Sebelumnya saya mau ini dulu ya, share survei untuk pribadi saya, untuk data pribadi saya.
Ya, silakan Pak.
Di kolom chat silakan Bapak Ibu peserta. Ini yang pra workshopnya. Jadi setelah workshop ini apakah ada peningkatan entah itu kemampuan atau pengetahuan dari topik yang telah diberikan gitu ya. Silakan bisa diisi di sini. Kalau yang tadi ketinggalan survei pre-workshopnya, ini saya share lagi. Ini yang kedua yang pre, yang pertama yang postnya. Oke, kalau kesan dan kesannya sih sebenarnya saya sangat terima kasih sekali udah mau diundang di acara ini. Terima kasih buat Universitas Pertamina dan Geosoftware Community sudah mengundang saya. Jujur nih pengalaman pertama saya mengisi kegiatan semacam ini. Biasanya saya jadi panitia yang buat acaranya, tapi sekarang diundang jadi pembicara gitu ya. Ya ini pengalaman yang sangat berharga buat saya. Makanya saya minta saran dan masukannya melalui form tadi supaya saya bisa tahu apa yang kurang dari diri saya dan apa yang bisa saya kembangkan ke depannya. Mungkin itu aja sih. Terima kasih juga partisipasi peserta yang atas pertanyaan-pertanyaannya. Mohon maaf kalau jawabannya tidak sepenuhnya memuaskan. Saya juga masih banyak belajar, jadi kita di sini sama-sama belajar gitu ya, Bapak Ibu. Nah, kalau misalnya ada pertanyaan yang masih belum bisa dijawab di sini ya, kontak saya ada di panitia ya, jadi bisa diminta, nanti langsung japri aja ke saya, nggak masalah. Mudah-mudahan kita bisa diskusikan bareng-bareng gitu. Itu aja sih, terima kasih buat penyelenggara dan para peserta sekalian. Mohon maaf kalau banyak kekurangan dari diri saya. Itu aja, Mbak Ratu.
Okay. Once again, thank you so much, Mr. Fadil, for your time and also for the presentation. So before we end the session, I will conclude Mr. Fadil's workshop. So from Mr. Fadil, we have learned that mudflow is another powerful tool for investigating the concentration of contaminant in water flow. And mudflow can be used to investigate water pollution so we can make our groundwater safer and healthier. And that's it for the third and last workshop for the day. I would like to thank all the participants for your enthusiasm and also your participation. And before we end the session, I would like to ask you to turn on your camera because we are going to have another photo taken for documentation. Please turn on your camera.
Please turn on your camera, and in my laptop there are 5 slides, so please hold your pose within seconds so I can take our photos. 3, 2, 1, cheese. Slide number 2, 3, 2, 1, cheese. Slide number 3, 3, 2, 1, cheese. Slide number 4, 3, 2, 1, cheese. Slide number 5, 3, 2, 1, cheese. Okay, that's all for a photo session. And in the chat room, you may fill out the form for your attendance list, so we can email the e-certificate to your email. Thank you.
Yes, before you leave, I would like to thank you for your participation and your enthusiasm once again. I, in the name of the committee, apologize if there's any mistake during this session and personally apologize if there's any mistake in my words. Please don't forget to fill out the form in the chat room that was shared by our crew. It's for your attendance so that we can email you your e-certificate. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Have a good day.
Terima kasih.